Thanks for giving me the opportunity to present the IDSA reference architecture model. And maybe before I start with my slides, a little bit of history. So we with IDSA, we started back in 2015. And the reference architecture model version 1 was really the first deliverable of IDSA. As said in the first version, describing what is a data space as really a novel concept back in 2015, 2016. And so we had the ambition to describe the overarching concept of a data space from multiple different perspectives, because as I said, it's a comprehensive framework to share data while maintaining data sovereignty. We've been working on the reference architecture model. We followed up with a version 2 and a version 3 on a yearly basis. And then version 4, well, it took us 3 years to come up with a version 4, and now we are working on version 5, and Ilknur will have a word on that later on. So you see the cycles are getting slower. I think we have achieved a certain degree of maturity in this document, and also in the idea and the concept of the data spaces. And today it connects to various other initiatives, approaches, and documents. But still, I like this document because what you will find inside the reference architecture model. The idea is that you really have your guide to data spaces, how to build a data space, more from the techie perspective. It's not so much really business oriented and legal oriented. There we have our IDSA rulebook for, but it shall be really more or less a practitioner oriented guide to design and implement architectures for data spaces. So what you will not find inside the reference architecture model is really a very clear technical blueprint. This is how you have to implement each and everything, because we know that data spaces cross different domains, so it has to be applicable in various domains, but it also has to be implemented on various technologies, because, well, data are different and the requirements towards data are different. So do you stream data? Do you want to connect an IoT device to another IoT device? Do you work in the cloud with really super scalable infrastructures? So there are some design choices, how you implement such a reference architecture model inside your tangible architecture, in your use case, in your domain, and so on. There are various questions that in the end you will have to answer, but it gives you a good guidance how to get started and what are the things that you have to consider and think about. But it also gives you a couple of degrees of freedom. So it's an introduction to software architects, but it's also, it shall support good practices to support everyone in developing data spaces. I briefly mentioned, so the reference architecture model, while it was our first deliverable, it's not alone anymore. So the IDS reference architecture model is a document where the IDSA members work together. So in the IDSA, we are a member-driven association with working groups, and our members inside the working groups, they create our documents, including the reference architecture model, which is maintained by our architecture working group. But if you build such kind of an architecture, and I explained that you have a couple of degrees of freedom, at the same time, you want to validate if your given system, if your given data space is compliant to what we describe in the reference architecture model. And this is subject of the IDS certification scheme, where we can today validate if an IDS connector is compliant to the basic rules of the reference architecture model 4. So this is, in general, the idea that the certification scheme can provide you a certificate that you're compliant to the given thing. And this certificate, it's not only a paper-based certificate, this also has a digital representation, similar to what we have nowadays in verifiable credentials, but for the reference architecture model, that's subject of REB 5 to make our structure really compliant with concepts like verifiable credentials. And then the third important thing, and this is not the IDSA job, is to work on compliant building blocks. So software implementation, source code that you can directly use to build components, connectors, to share data and to use data in the end. But of course, we have an overview. And here, for example, you should take a look at our data connector report. That gives you a good overview on connectors that are under development, that have achieved a certain degree of maturity, and if they are compliant to IDSA or not. So we do not provide you this portfolio of open source or closed source building blocks. We don't provide them, but we have a view on that. And then we have the IDSA rulebook, which connects the magic triangle with each other. So this gives an overview in this idea of bluff thinking, so business, legal, operational, functional, technical agreements, how you want to set up and govern and maintain a data space. And well, in the end, that is our job, to develop all those different deliverables and to ensure that they are consistent with each other. That means that we have to maintain a life cycle that if we update one document, all the other documents need to follow in a timely manner. But let's get into the subject at hand, the reference architecture model. And what I will provide today is more or less an overview of what is written inside, to give you an idea, a glimpse of where you should start reading. I always recommend to read the whole document to get the overarching understanding. But I will provide you an overview on what is written where and what is explained where, so that you can also choose what are the sections apart that are really of relevance for you. So what we do in the RAM is we have layers and perspectives. So the layers address scopes, so the more business related scope. So I'm not completely convinced that business is really in the end the right term, but what we describe there is more or less a role model for data spaces from a technical perspective. The functional perspective, where we describe the functional requirements, an information model, an information layer that describes what kind of information are required to exchange data in a data space. So spoiler alert, it's not about your data model that you have to use for your data, but we explain how you can use and connect your data to such an information model. The process layer describes the core processes, how participants and roles interact with each other in a data space. And then the system layer explains in more detail how you can really build components and what are the real requirements and core concepts to build the key components inside the data space. And then we have our perspectives. So we have three perspectives. They are perspectives because you see they are cross-cutting. Those perspectives have cross-cutting aspects that are relevant for each of those 5 layers. So we talk about security. So what are the security aspects inside a data space? Certification as an overarching concept, and then the governance thing also as an overarching concept. And I briefly explained this slide already. So what you will find inside the different layers. So also inside the slides, and I'm pretty sure that we will share the slides afterwards so that you can also find this one. This is the idea of the different layers, and finally the perspectives as well. So what is the idea of the different perspectives? And before you start reading, when you go from line 1 of the document to the end, you will find in section 2 the section context of the reference architecture model. That is something like, well, non-normative, but it's illustrative. It explains how the concept of data spaces and the reference architecture relates to other aspects. And here in this word cloud, you will see that well, we have some things that seem to be important, like industrial data sharing. Interoperability is a key aspect. Data markets, the concept of data-driven business ecosystems. So we explain here how all the different things connect to each other. If you take a perspective from manufacturing, if you're asking, and this was a question that has been asked a lot in the recent years, how does it relate to blockchain, for example? And there is a certain relationship to blockchain or distributed ledgers, and how it relates to IoT and all those different concepts. So this is interesting to just read and understand, okay, where does this fit in? Because, well, data spaces, they are not the silver bullet that will resolve all the issues that the industry has today. We need a lot of other approaches as well. And things need to connect to each other in the end, because what we want to have in the future is that we want to be able to exchange and share data between the different partners, organizations, in real world use cases, while maintaining data sovereignty, meaning I need to be able to express how can you use my data afterwards, because we want to establish this data economy thing, whatever that means in the end, but an economy that is driven and supported by the usage of data. So this is illustrative and from my perspective, a good read to understand how those things fit together. But let's dig a little bit into the details. So this is one of the key graphics, I think, that is used in various contexts that we've been working on. There is a very key concept inside. This is where I put this red rectangle inside. So what is important in a data space? That data is always exchanged between two parties, from a data provider to a data consumer. There is typically not such a thing like a man in the middle. You need some supporting roles that will get access to metadata, for example, that need to use metadata. But it's always a peer-to-peer transaction. And this is an atomic and key concept. Of course, what you want to do is you want to establish such a data supply chains where you connect multiple consumers and providers with each other. So this also means that you can have multiple data providers. Think about IoT data, where you collect a lot of IoT data from different providers into one data consumer that uses to use those data to create an AI model, for example, for predictive maintenance. And then this data model will be also shared later on, maybe to another third party. So this is how we can connect all those different data providers and data consumers with each other. But the idea is, well, it's not all about putting all the things into one data lake and everyone can access it. It's always the idea of having those data supply chains. So and therefore it's important to distinguish between the data provider and the data consumer. The data provider, the one that is in charge of making the data available and sharing it, setting data usage contracts, and the data consumer accepting those data usage contracts and using the data in any degree. And this includes concepts like also code to data. You will not always share all the raw data. Maybe you will just send as a data consumer a query towards a data set and you will get a subset or whatever. So multiple variants are here possible. And then we need to distinguish between, on the data provider side, the data owner and the data user on the consumer side. So these are roles that are not typically directly connected to each other. But I, as a data owner, and I know you cannot have something like ownership on data because it's an intangible asset. But I mean, you know what I'm talking about when I say, well, it's my data and I have to take care about that. But I'm a person, maybe an organization, and have no direct access. So we have the data provider as really a technical component and the data owner as the one who has the right on the data and has a say how data can be used afterwards. And on the data consumer side, likewise. So the data consumer is a technical artifact, but I, as a user, sit in front of my screen and want to make use of those data anyhow. And those are also very important concepts that we need to distinguish. And then you will see a couple of other services and components that will enable this data exchange. For example, this idea of a metadata broker. So having a yellow pages service where I can find the different participants in the data space, my partners that I can exchange data with, all the different data offerings that I want to use, for example, in the end. So this is Yellow Pages service where a provider can publish data and the consumer can find the data afterwards. The concept of a clearinghouse, so to support any kind of observability maybe afterwards, billing and so on and so forth. So these are really the core concepts, and I will go to most of them later on in my presentation. So this is how we use it in IDSA, which is a typical figure to explain so what is the core role model. And I also brought something for you that I would just briefly go inside. This is a new figure that comes from CWA, so a workshop agreement inside CEN, where we work on some pre-standardization activities, where we put this idea that we have a data provider and a data user. They somehow exchange data with each other based on the Dataspace protocol, which I will explain later on. As you will see it on the bottom as a core foundation, and then the concept of catalogs, data usage contract, the data transaction, shifting data from A to B, whatever that means, the notion of a data product. So how can I describe data as a tradable asset? And on top of that, things that we do not do in IDSA. For example, that I, as a person or as a data rights holder, I need to grant the rights to someone that data might be shared or used afterwards. So this is a very interesting view graph because it connects the work that we do in IDSA to a lot of other work that is conducted in other organizations. So this just as a hint if you are interested in how this connects to other things. But that's not part of the reference architecture model, for just illustrative here. So let's move on. second part of our layers is the so-called functional layer, where we describe what are the general functional requirements towards the data space. So what do we want to achieve? And this is described there in more details. Trust is a very important foundation. I will not share my data with you if I don't trust you. So and then the question is, how could I trust you? What are the measures? What are the measures? How can I measure that you are trustworthy? What are the characteristics of trustworthiness in digital ecosystems and data-driven ecosystems? This is one of the core questions. Then how does it relate to security, cybersecurity aspects and data sovereignty? So the reference architecture model is not a cybersecurity guideline. It's about data sovereignty. So how can I sovereignly decide who is using my data and under which conditions? But it's somehow connected to security aspects, because security is a key aspect when it comes to trust in the end. How can we build such an ecosystem of data? So as mentioned before, how can I share data? How can I make data available that someone else can find it and can understand it? How can we provide standardized interoperability? So having a foundation to collaborate inside such an ecosystem is based on interoperability on the one hand side. And the other aspect is, of course, if I want to have a sovereign and free choice of who can use my data or who is a provider of my data, well, I only have a choice if I have different options that I can choose. So interoperability is a key enabler there. The key question then afterwards, how can I really create value out of data by using apps or algorithm in general, and then establish data marketplaces in the end. So this is a little bit the idea that we describe here. So what are the drivers for the reference architecture model? So, and then I mentioned briefly before that we have this notion of a data product, or data as a tradable asset. This is part of the IDS information model, the IDS information layer. And this is structured based on this 6C hexagon. So this was a funny exercise when we started with that. So we said we need to structure this data as a tradable asset a little bit. Then we said, so we need to take a look at the different concerns. And then, well, computer scientists sitting in a room with a lot of coffee, then we made up the idea, so let's make this 6C hexagon, which looks like a sugar molecule. And so all those things start with a C, while it doesn't always really work out good in the title. So this is why we have the 6C hexagon. And this explains, so what are the different concerns that you have to think about when you want to create a data product? Of course, you need to describe the communication part. So where can I find the data? What is the endpoint? What is the message that I have to check? Which operation do I need to invoke? You have to describe this, and not so it's not bound to some kind of message-oriented middleware. You can also use streaming, pub/sub mechanisms, whatever, but you need to describe, so what is the endpoint? How can I consume this data from a communication point? You need to provide context information, and here don't confuse this context with context information that you have, for example, in the FIWARE ecosystem. So context is here really basic information on what kind of entities do we have, information on space and time and such things. You need to describe the content that someone will receive. So this is data, but what kind of content will I get? What's the representation? It's a CSV file, it's a JSON file, whatever. What kind of resources do I have? Where can I find those instances? Things like this, which is strongly related to DCAT. And then we have the idea of the concepts. So you have to describe, so what you will find inside beyond the technical representation. Now I know it's a JSON file, but what is it about? So it's about weather data. I'm using this ontology to describe the weather data. So this is the idea of the concept, where we can, in the IDS information model, have a rough description of what you can find inside. But this is the extension point where you can add your extensions, your vocabularies, your ontologies, whatever, to the IDS information model. This one is a community of trust, so you have to describe who is the participant. I'm Sebastian, I'm from IDSA, I'm ISO 27001 certified. We have a frame contract. All those informations also need to be described to understand who am I talking to. And then finally, the commodity aspect. So what is the provenance of the data? What is the quality? What kind of policies do we have to the data? You're allowed to use it, but only within the next 7 days, or only when the sun shines, whatever the policies are. And And of course, you want to put a price tag on the data. And you will see that not all those things are mandatory, but this gives a good overview what the key concerns and aspects are if you want to make data available as somehow as a tradable asset. We provide this information model, first of all, as a conceptual generic model in the reference architecture model in UML so that everyone understands it. But we also maintain a declarative format of that, so an ontology that you can use. And there is also a library available in Java that you can use directly inside your code. So this is a little bit what we need to understand when we want to share data as a tradable asset or data products in a data space. And then we describe in the reference architecture model the basic processes. And this starts, of course, with what is a technical onboarding into a data space, into an IDS-based data space, where you have multiple roles that need to somehow interact with each other, because you as a participant, you want to set up your connector, make it available, and then put it into operation so that it can offer and use data. But you will need something like an IDS certification first. So your connector needs to be checked if it's interoperable and if it's trustworthy. And after this information was given, it will be as a paper-based certificate in the end. This proof of certification needs to be put inside a claim by an identity provider, and so those claims are available. So during runtime, you can then check. So this is Silvia connecting to Sebastian, and I can validate that Silvia is really working with an IDSA against a given identity provider. This is a very key concept because, as I said, we want to establish trust as a basis inside data spaces. Then, when you're part of a data space, your connector is available and running, and you have connected your data to this. But, well, wait, you want to create a data offering. This is one of the key aspects. So it's not only that, well, I connect my database to a connector and off we go. No, you want to describe something like a self-description for that one. So describe what kind of data you have. And I have explained to you about the information model and the idea of the data as a tradable asset before. So you create a data asset that you want to offer somehow as a technical description. There is an endpoint how you can use this. This is a format, and then typically you would like to add some semantics to the data so that someone else will understand what am I talking about. Of course, you can choose to don't use a vocabulary, which is also fine, but of limited use in the end. But there are use cases where it is also relevant. But typically the second step is that you add the semantics to the data. So those are the vocabularies that I use. And then when you have explained, so this is my vocabulary that I use, then you want to publish the vocabulary somehow, because, well, someone will find your data offering and then he or she will check, okay, do I understand this data? What kind of vocabulary is used? So it will be shared, it will be validated, and then it will be published so that someone else can understand it. Or you just choose and say, well, I reuse an existing vocabulary, and then you don't have to publish it, of course. So this is how you, in general, create the data offering, and you will understand that, well, there is a lot of work to be done to just create a self-description to make the data available in a way that someone else can find it and can use it. So, and after you've created your data offering, publish the semantics, the vocabulary of your data, then you can publish this data offering. And there are multiple ways possible. So what we talk a lot about is that we have some kind of catalogs or a metadata broker, so a centralized service where you can just publish your data offerings to, and then you have a catalog where someone else can browse and see, okay, those are cool data, I want to use it. This is one perspective, but of course, because we have a network of partners, each participant can just go and crawl all the different participants, and you can create your own semantic model, your own graph, where you find, so this is my network, and this is a data set that I can find and assess. So this is also an option. We do not mandate one of those mechanisms to have a centralized or a completely decentralized thing. This is something that is really domain and use case specific. So how do you want to set up your systems? Do you want to have more centralized here with this catalog information or decentralized. Both is possible and subject to a lot of different questions, including a resource question. So if we talk about an IoT data space, then maybe it's not an option to crawl 10,000s of different connectors and create your own model of all the different data sets that are available because you have limited resources. Well, if you're running on Azure or AWS or whatever big cloud, well, then resources are maybe not the big problem, and you will just have all the information on your end. So one important aspect here, we always talk here in IDS about self-descriptions. Self-descriptions of data sets. Those should not be messed up with the Gaia X self-descriptions, a term that is or was used there a lot. This is more about claims. So there is a difference in this. While it's the same name, the concept is differently. So now I've published my data and you have found it, and then we want to agree on a certain kind of contract. And this is, of course, a process where two parties have to negotiate between each other. So this is my data set. I will give it to you for 10 days and you can use it. You're not allowed to resell it, and I want to have 10 euros for that. And then you can tell me, well, Sebastian, I will only give you 5 euros for that, and then we sign a contract, and then we can start data sharing. But this is the process perspective, and this is in far more detail in the Dataspace protocol, where we have to really, in more technical detail, describe how the two connectors can interact with each other to request a data offering or to create a data offering, to accept the given offering, and then have an agreement between both parties that can also be verified then. And then this data contract will act as a foundation for the data exchange, because what you will do is, after you have such a data contract, you will feed it inside your systems, especially as a data provider, and provide the data set that was subject to the data contract, and maybe you want to configure your data access policies based on such a contract. So now I've sold my data to Silvia, so Silvia has access to the data for a limited amount of time and so on. Well, this is the idea of this contract negotiation, and then afterwards feel free to share data. And this is the core concept that we have also here, that we have to distinguish between the control phase first, where we create a data offering. A data offering can be published and discovered. The contract is negotiated, and after the contract negotiation, you can invoke the data operation. So we move to the so-called data transfer phase, where we somehow have the result of the data operation, which might be something like just one request or one message, or a continuous exchange of data. So different things are possible here. And then one of my most beloved topics, semantic interoperability, which is also described here. Because, well, for me and for IDSA, it's easy to talk about semantic interoperability. I briefly explained we have this idea of the design time, where I create my self-description of the data, my data asset. I invoke an existing vocabulary to annotate my data set, or I create a new one that I will publish afterwards. Well, and then you show off and say, well, I want to have your data, Sebastian. And then what you will do is you will get my self-description and say, well, that's a good kind of data. I want to use it. We agree on a contract. And then, well, you will go and receive the vocabulary, check the vocabulary. You can validate the schema if it's a valid schema. And what will happen afterwards? Well, as a matter of fact, you have to implement something. So any kind of interface that fits to my endpoint, to my offering. In best case, you rely on a standard. So you have all those interfaces, all the structures already implemented to consume the data. And if not, well, you have a magic fairy that will implement it automatically, or a group of software developers that will then have to start typing and create all this glue code to connect the things to each other. That's not subject of the IDS reference architecture model. That's your work, folks. All things of predefined data planes that you can use to use and ingest data immediately. And then after you have implemented that one, then you invoke the operation. You receive the data, you validate the data typically against the schema, and then this is then when really the magic happens, when you really make use of data, do anything with it, put it in your database, lock it away, mix it together with other data. But that's not subject of the reference architecture model. That's again your job to do something with the data afterwards, inside the connector, beyond the connector, depending on the usage policies given. So what I explained here, this is subject of a paper that was just published, Semantic Interoperability in Data Spaces, which explained the IDSA approach in a couple of pages. What is written, the reference architecture model wrapped up here in a single readable text, but also connects to the general approach to semantic interoperability. There are a lot of other things that should and could be considered here as important. This is subject to section 2, and then we have a couple of good use cases, good examples and best practices also in the document that you can read and consider as relevant also for your project. So after we have gone through the processes, there is an important aspect of using the data. I mentioned that. And we have always a notion where we talk about data sovereignty, about policy enforcement. So we have agreed on a technical policy, and then I hope that you can enforce it in technology afterwards. So basically the fundamentals are nothing new, and we compare it always to this XACML scheme where you have a policy enforcement point where the data comes in, and then the policy enforcement point has to decide, the policy enforcement point needs a decision. It doesn't decide, it needs a decision. What can I do with the data? Do I have to modify it? Can I give access to the data or whatever? And so he will ask a so-called policy decision point. Then we describe different ways when you can decide. It could be a precondition, it's an on condition, so during usage or after usage as a post condition. But this policy decision point needs to somehow decide, is the usage of this data set now granted or not? Therefore, you need information. You need to understand who is that. You need to evaluate the policies that are given and get all the right context information to make this decision. And this could be a quite complex task. But while this concept is easy, the devil is really in the detail. And this policy enforcement leads to other components, as mentioned before. So we talk about a policy enforcement point, which is something that is typically used at the policy decision point that shall do a decision and therefore invoke a policy information point. So I need more context information from my systems, but maybe also beyond my systems. So I have to find information from external partners as well to do this decision. And as I had this example before, you're only allowed to use it for a couple of days. Maybe it's also that an action needs to be triggered later on. So the data has to be deleted after 3 days. So this doesn't execute in the policy enforcement point, but a PXP, a policy action point, will get this information and will conduct an action then in the future when it's planned. So this is, well, a complex thing, and we have a lot of more information on that. So, but all those things happen in the end in an IDS connector. This is explained in the system layer. So the connector is really as a key component, which is, well, not really magic. In the end, of course, you will have some kind of hardware, some virtual machine, maybe some operating system. And then what we typically mandate is the usage of some kind of container management, may it be Kubernetes, Docker, whatever, so that on the one hand side, you can scale your systems, you can scale up your system, especially in cloud-related scenarios. But likewise, you can isolate the different container parts to each other to achieve some degree of security. And so then we describe an overview of this connector approach. So of course, you will have some APIs towards the data space, and this is covered more or less in the data space protocol. That's a right part with the lollipops. You want to connect it to your internal system, so to your database, to your administration interfaces and so on. That is to the left part. And inside, you should think about a couple of things. So, and this is not a wire diagram where you have to implement each and every connector exactly like this, but explains you, so what are the different concerns that you have to think about. It may be authentication, authorization, may it be any kind of data router to connect the external world to the internal world, policy enforcement, the policy engine, contract management, metadata management. All those things are things that you have to consider when building your connector. And of course, the system layer also explains how other components that you want to use in a data space are structured and what their preferred way of working is. I would like to switch a little bit to the security perspective as well. The security perspective has various different aspects. One is about identity and claim management, but it also deals with, which is about digital identities for organization, claims, trust anchors. And again, sneak preview, this is an aspect that we will have to update in RAM 5 a lot, to update it to more modern mechanisms. But it also explains depends on how you can secure the platform, how you can secure the applications, how you can secure the interactions between the different IDS components, because you will trust only in each other if you know that you have a pretty secure platform on the other side. And an organization that can take good care about your data. And of course, usage control. I briefly mentioned the idea of data usage control. So again, a little bit of fresh start here. So that is, well, in the end, just an extension of access control. So we want to do access control, but not at the data provider, not only at the data provider side, also at the data consumer side in the end. And so the question is always, so you have some obligations inside, and here in the example with regards to security policies, application context, a device, a role, a location, whatever. And then you ask the question, do I grant usage or not? And then this is not only a true or false decision. Yes, you can get access to the data, you can grant the usage, but only for 3 days. Yes, you access the data, but the owner has to be informed because, well, I will invoice you for each time you use the data. Or for example, for GDPR-related reasons, yes, you can assess, but I need to lock it down that you have assessed the data. And likewise, no, well, you tried to assess the data, you weren't allowed to, and I have to report this, I have to lock this somewhere down. So this is the general idea what we want to implement. And then we see, so, okay, data usage control is an extension of access control. So the provisioning, what is typically access control in past and present, now you get access, but also we want to put obligations on top of that. You are not allowed to forward it. Don't put this video on YouTube, or maybe, yes, you're allowed to put it on YouTube. Then you have to delete it after 3 days. You're not allowed to bring it together with other data sets and so on. This is a little bit the idea and explained in the reference architecture model, because what we want to achieve, and you will say, well, most of the things we do it already today with some kind of contract or organizational rules. The idea is to move this slightly more to the right, to get more technical enforcement of such policies. You have the assurance that, yes, it will be really implemented and enforced in technology. I doubt that, at least in my lifetime, we can force everything in technology that we can put as a rule for a data set, but at least we want to push it a little bit to the right. And here again, the job of IDSA is to talk about the language for the specification of data sovereignty. So in practice, how to use ODRL for that one, and then how to use this also in technologies. And IDSA is not developed technologies for data sovereignty implementations, but at least we have a good view on what is happening here and there. And so I think this is the last slide on this topic. One important concept that I want to bring to you is this usage control onion. Well, I don't like the term and I don't like the figure, but it's an important one because it is really complex to think about this topic of usage or distributed usage control enforcement. We have a lot of control when the data is at my connector side. I have full control about that one. When it leaves my connector and goes inside your connector, I lose a little bit of control, and I have to understand, so what can I really enforce there and what not. But when it has left the connector and is somewhere stored somewhere in a database, then you will lose again some kind of traction on that. Well, some organizations have the weird idea of making backups. So will you punch hole in the tapes if you have to delete the data afterwards? Well, you lose part of the control and the concept is getting more complex. When you put it inside an application and mix it with other data, it's getting more complex. When you put it to the client system, you're even losing a little bit more track on the security aspects. And when you put it to the screen or when you print it out, you will even lose more things. And you will tell me, well, Sebastian, when you print it out, I can do some colored dots on the page that you will not see, and so I can track the provenance. Yes, all those concepts exist, but the complexity really raises the farther you get away from the data source. And this is what you have to consider and think about. So what kind of policies can I attach? What can be enforced? And maybe do I have to rethink my whole architecture because I cannot really grant all the different requirements or obligations that I have when I do it in a typical way. So a lot of food for thoughts here into this direction. We have a paper on that, usage control in IDS, where far more details on this subject are described. So I will speed up a little bit for my last slides. So there is a certification perspective, and I will not go into too much detail of that one. So we have a certification scheme. that is typically structured like a certification, where we have accredited evaluation facilities that can do a third-party evaluation, and there is a third party that oversees all the different activities. And then we have the International Dataspaces Association, which provide the rules. So we provide the certification scheme, we provide the criteria and the mechanisms how a certification body can approve an evaluation facility and how an evaluation facility needs to conduct those things. So this is described, and then we'd have two different variants for certification. One is for the operational environment, so more or less soft assessment. Are you able to run your data center? This is a lot based on 27001. So the typical standardization. Yes, you can manage a data center wisely, including does your server room have lockers? Do you have any kind of processes for backup and restore? All those things. Then we have different levels for that one. An easy entry level where it's a self-assessment, so not a third party, but a first party assessment, and then third party assessments in two more assurance levels. Likewise for the components, so we also evaluate the components. So is your connector really implemented as it should, including improve for interoperability and some cybersecurity related aspects. Again, as a first party assessment, so as a self-assessment, or a third-party assessment by evaluation facilities. This is what you will find in more details. And then finally, we have the governance, the data governance perspective, which is a lot of different things that are addressed there. Data quality is a very important aspect that needs to be addressed in much more detail. The relationship to the rulebook, how to deal with data as an economic good. What is a good data governance model? If you want to provide data to a data space, what kind of data governance mechanisms should you implement? And all those different things are described there from the governance, from the data governance point. So that was the rough overview on the reference architecture model 4 to give you an overview of what you will find and what to expect, and to guide you a little bit while reading. Let me close with those two slides, and I will start again with this one. It's a guide for your practical implementation. And why do you need that? Because you want to achieve data sovereignty, and that's a continuum. It's not only that you have those three levels that you want to do. You have to understand, so what do I want to achieve and what are your goals? What you will need on the foundation is standardization, standardized interoperability, so that you can easily connect to each other. You will need different ways for trust and certification, something more lightweighted because, well, we're in a closed group, we know each other, the data has less value or whatever, up to, well, that's super valuable data because we are talking about health and IP rights and whatever. Then you will need different trust mechanisms. And the key question is, what is the functionality of your usage contracts? Because the first thing that you want to have is the interoperability thing, that your partner understands the contract that he just signed. The second thing might be that you want to have a trace for that. So you want to have a signature really on this contract that he did not only understand, but approve. Yes, I understood the data. And then to think about what kind of enforcement do I need. And there are various mechanisms for enforcement of usage policies in technology, including things we boil it down to hardware anchors and put it into encrypted enclaves or homomorphic encryptions, all those cool things that we want to see. But this is where you have to think about, what is my use case? What kind of technologies do I have in place and what are the needs from my data set? And then you can follow on those things. And this is where a lot of development will be seen in the future, how we can really enforce such policies and technology. So, and to close really with that one, as an introduction for, I think, Ilknur's next talk, we're preparing RAM 5. We have the Dataspace protocol as one key specification to implement data spaces, and our work in the reference architecture and rulebook are already subject in some standardization processes, like in SC38 for cloud computing and distributed platforms, but also in SC41 for IoT and digital twins. So, Silvia, questions now or later?
I think we can wait later and make all together. You can stay with us up to...
I will be here.
Okay, perfect. So
great.
Please,
thanks.
Ilknur. Thank you, Sebastian, for this amazing presentation and the insights. And thank you for the last slides on specifying the different levels of security that we can implement. And now we welcome Ilknur Chulani to explain us what we can expect on the new version of RAM 5 and how we can contribute to it. Thank you, Ilknur, for being with us.
Thank you very much, Silvia. And also thank you for inviting me to be here. It's very nice to be with this interesting project. I think we can find a lot of energies with PLIADES and RAM 5. So today, as Silvia mentioned, I'll try to explain a bit what we might have upcoming in RAM 5 and also how you can contribute if you are interested. Hopefully that's the case. Also to introduce myself, I'm Chulani. I work with the tech team at IDSA. So what we will cover today, first, why we need a new version. So what are the upcoming changes in RAM 5? When we expect to complete this work, who and who can contribute and on what topics. Also, how we work together, what's the process we use for co-creating RAM 5. And then I'll finish with some resources, some links about where to find more details. So first of all, what was our motivation for starting a new version of IDS reference architecture model and what you can expect as part of your work in the PLIADES project? So we want to, in this new version, align the reference architecture model with the latest developments that is happening in IDSA and also in the larger data spaces community. So as Sebastian mentioned, we just released the version 1 of the Dataspace protocol, which we are trying to make an ISO standard for data spaces, for data exchange. And then we also have the rulebook. Now we are working on a new version of that with some new improvements, new concepts. Then we also have the Data Spaces Support Center blueprints. This is an important initiative in the Data Spaces ecosystem, and a lot of cool work is happening there as well. So we want to align everything together and make sure everything is coherent. So we will make sure the new version of RAM will be on the same page with all these different things going on. Secondly, in RAM 5, you can expect to see more decentralized approaches. So in RAM 4, we did talk about these a little bit. Also, we described you can do things in a federated way as well. But we didn't elaborate on them a lot. We didn't provide a lot of architectural guidance. So we hope to do this in this new version. And this will mean some impact on, for example, the data space governance, on the trust framework, how the participants can trust each other. If it's decentralized, as you know, it can be managed with different concepts, different frameworks. So we will work on that a bit in RAM 5. Then thirdly, we want to make sure in this version that we provide sufficient guidance for different roles in data spaces, because in RAM 4 we focused a lot on the participants, how you can onboard a data space, how you can do contract negotiation, how you can do data exchange. But we didn't talk as much, for example, about the service providers, value added. We talked, but I mean, we want to provide more guidance about like what components they might need, what processes they might need, these kind of things. And also the same for the Data Space Governance Authority. We want to elaborate a bit more how you can, what processes, what roles, what components you might need for governing a data space. There are a lot of other things we have in mind. For example, the information model will see some updates as well to catch up with all these different changes. For example, with the data space protocol, with also this new trust framework, etc. But also we want to present RAM in a more modular and flexible approach. So we want to create different sections that are self-contained, so that you don't need to read it as a whole huge book, but you could find some guiding user journeys that could tell you which parts you need to read based on your role. So If you're a service provider, maybe you need to read only these sections. If you're a Dataspace participant, then you need to read only these parts. So those are the things we will work on. Also, maybe I didn't mention it here, but we had the security perspective in RAM4, and we will be renaming it to the trust perspective. And so it's one of these columns here in this small picture that Sebastian also explained earlier. But this also reflects the fact that we want to focus more on trust than cybersecurity in RAM4. So when do we plan to do all of this? We want to have a new version, the complete version finished or released by the second half of next year. And to get there, we already started some work. So last quarter, the beginning of this year, we started creating a new repository, for example, started doing some organizational tasks, etc. And now we are picking up speed. We are doing some workshops, which I will give you some details on in the next few moments. And we will continue this way. And who can contribute? So IDSA members are all invited, but we also have a special process for interesting projects like PLIADES. So you are also very welcome to join us in this endeavor. And we support you with some project management and organizational aspects. So just to give you a teaser, these are some of the topics that we will be working on in RAM5. For example, the decentralized approaches, as I mentioned earlier, trust frameworks, usage control, which was also in RAM4, but we will elaborate more on them. Interoperability, as you know, is a big topic these days. So the European Interoperability Framework, for example, how to align with that. Observability, how to do it in a decentralized way, and how to ensure traceability, etc. These kind of interesting topics. Information model, data value creation, data governance, Dataspace governance, certification, also relation to other Dataspace initiatives, like the examples I gave earlier, and a lot of other topics related to Dataspace. So if you are interested in working on these things and maybe also learning along the way, feel free to join us. And I want to emphasize that we don't only need very technical, capable experts like system designers, software architects, etc., which is very, very valuable for us, especially when we will be doing the systems and process layer, for example. But we also need people that are more generalists, like who have the Dataspace concepts, because we will also be creating more general sections, like we have a foundation section, or Sebastian mentioned earlier, the context of RAM section. So we could also use some support there. Also, as I will tell you in the next slide, we need help also to visualize things, to create some nice graphics. So any kind of help is welcome for us, any kind of support. So don't think that you only can contribute by writing some text in the RAM, even though this is a document. You can also help us by creating some cool architecture diagrams or role model diagrams, etc. Or you could also be involved by joining our workshops. We organize specific workshops on specific topics. So you are most welcome to join there and express your opinions based on some research you are doing, for example, or some industry requirements that you have in mind that you see in some use cases. So you are very welcome. Also, we really appreciate if some people want to take the lead on a particular section, for example, if you want to be the maintainer of a particular section and help organize the work with other contributors. So how do we work? Just to give you some insights, we start with a project plan, project outline document, which we broke down our activities into different milestones per quarter. Then we carry this work to GitHub. We create some issues there for each of these different activities, because GitHub is where we create, where we use for content creation for RAM5. So But that doesn't mean you cannot contribute if you don't know GitHub. Like, we also can help you and can support you if you want to get familiar with that. So we use the typical open source workflows. So we do things like branching, pull requests, approval processes from peer reviewers, etc. And we use tools like Git issues, Git milestones. So we do not develop code here, but we use the best practices from the open source development communities. Then we also have a bi-weekly touchpoint call where we connect contributors with the maintainers. So we can discuss issues there. If you want to work on an issue, you can give a heads up there, for example, align with other people working on that. Then we also have a quarterly working group architecture meeting. This is mostly for IDSA members who are in this working group. Then they review the work we have been doing in that quarter. We give them a heads up a few weeks before with the work we have already done. Then they have a chance to review and give feedbacks or approve the release for that quarter. So that's our process. Hope it's collaborative and transparent. We try to make it as much as in that manner. So if you want to contribute, how you can start? You can let us know, first of all. We have a registration form, and I'll circulate these slides later on, so you can fill in that. Or you can approach me, myself, or Sebastian, spoke just before me. And you can join our bi-weekly calls, or you can join the workshops we are organizing. Also, I have a few resources here for you. So the first few links are public access. The other ones you would get access only after you contact us. And if you are interested in working on M5, then we would add you to these shared spaces. And just to give you a teaser, these are the topics we are working in this quarter. So we have some workshops. I put the dates here also in case anybody is interested, then you could contact us and we can already get you in the loop. So for example, on trust, we are having a second workshop, same thing for observability topic. And business and process layer workshops we are organizing in May, for example. So that's it for now from my side. Please just check it out. And if you are interested, if you think the project work can relate to what we are doing, please feel free to join us through this form or email address. Thank you very much.
Thank you, Ilknur. Very interesting, all the activities that are running at this moment. And now I want to give the floor to Matthijs Punter. Thank you, Matthijs, because I know that you are in an official event, so and you make yourself available. Thank you very much for
no problem. But indeed, I'm not in my regular office at the moment, so. And also on a mobile connection. So hopefully you can all properly hear me and also see my screen. Is that correct?
Yes, correct. Perfect.
Oh, very well, very well.
Thank you.
So Matthijs Punter, I'm working at TNO, which of course is a partner in the consortium as well. But aside from the work in this project, we are also engaged in the Dataspace Support Center, as are many other organizations. I know also some of you are a part of the Dataspace's Support Center, for instance, the IDSA, but also GaiaX and several initiatives in Europe that work on dataspaces, the promotion of dataspaces, the trust in dataspaces, and so on. And one of the things we do, and I will focus a little bit on that, is building a common blueprint for dataspaces. And Ilknur already mentioned that briefly in her presentation. But maybe to start off with, let's say, the highest level view, and that is the European Strategy for Data. That was launched a couple of years ago with the aim of creating a common European data space or a single market for data. Well, those were the words of the politicians in those days. And that resulted in many different initiatives. It resulted in new legislations like the Data Act and the Data Governance Act, which we now all see come into effect. It led to the mandatory opening of the app stores on mobile devices. It led to more control over data. So that's the legislative part. But next to that, the idea was also to stimulate the setup of data spaces in many different domains. And you can see that in this picture. And we had the Digital Europe program. So next to the Horizon Europe program that is funding research, there's now the Digital Europe program that is actually funding the rollout of those data spaces. With funding for data spaces in many different domains, not all the domains mentioned here in this picture, by the way. Some have their own financing schemes, but the idea was that in many sectors of the economy, data spaces should emerge. And then, of course, the second objective, in order to do that, you need some commonality, especially since businesses are often active in multiple different sectors. So if you're a manufacturing company, then of course you are active in one or more manufacturing data spaces, but probably you're also using energy and you need to transport your goods. So you're also connected to the mobility data space and the energy data space. And even within those domains, you can have a multitude of data space initiatives. And this is where the Data Space Support Center comes into play. So formally, it is a CSA, Coordination and Support Action, that is interfacing with all those domains and which has as a main objective to create a common blueprint that can be used to set up data spaces in all these areas. And for us, the objective of such a blueprint is quite clear. Of course, it needs to directly support those projects, but also from a more higher objective, we need to get them to, I always call it the higher flight level, much quicker. So many challenges are exactly the same for all those data spaces, and you do not want to reinvent the wheel time and time again. You want to be able to focus on what matters in healthcare, in energy, in manufacturing, and a lot of things in terms of connectors and trust and all of that. You want to be able to reuse what is there. So that's one thing, faster. Secondly, it needs to be future-proof. So a lot of investment is being made in all those domains, and we want to avoid having a situation that in a couple of years' time we need to redo that because we've invested in legacy technologies or new things have come up. Of course, it will happen, but we really want to make sure that those data space initiatives are on the right track today. And finally, thirdly, I call it federations. We want to be able to scale. And this is important for companies because it will create more value because you can join multiple data spaces, but also for technology providers. And I think this also nicely links to the work in PLIADES. We want to develop solutions that can be applied in many different domains. And that's, of course, not only interesting from a content point of view, but also from a business point of view, because the market for those solutions is then also way bigger and becomes easier to adopt them. So we said we need to have a blueprint. Now, fortunately, we didn't have to start from scratch. A lot of material was already there. Technical work, like the work from the IDSA, also organizational work. Maybe some of you are familiar with the OpenDI project that launched a couple of years ago this paper called Design Principles for Data Spaces. And that document for the first time introduced in that time 12 building blocks for data spaces, both technical and non-technical building blocks. So that was the first step. We've contributed to that, and we launched in the beginning of last year a starter kit. And in that starter kit, we actually updated that list of building blocks. And this has resulted, first of all, into an intermediate version of the data spaces blueprint. Here you have it. So this is the new list of building blocks. I will go into more detail in a moment. And at the beginning of this year, we've launched version 1.0 of the Data Spaces blueprint. So the common blueprint that is to be used by all those. And we will further evolve that in the years to come. By the way, maybe as a side note, it is not that we are in some sort of ivory tower blueprint and spreading this to all those dataspace initiatives. It's really a collaborative approach. So we have a wide community of practice with dataspace initiatives, with technology providers, and together with them, we are developing this back and forth. Now, if you zoom into this blueprint, we have identified building blocks, and building blocks are essentially about the required capabilities that you need in a data space. And that means that it's not only about technology. It's also about business and organizational building blocks. Maybe it is even very important to start with that. We often see that people immediately dive into what's the connector and how do I do trust and everything. But if you don't have a good understanding of the business and organizational perspective, it is very difficult to make those technological choices. So compared to the OpenDI project, we have put a bit more emphasis on those building blocks, as you will see in a moment. Then for each of those building blocks, we introduced some core design decisions. What are the questions you need to ask yourself as a dataspace initiative when implementing this? And we've identified available specifications and common standards. And for that, we do not reinvent the wheel either. We refer to specifications that are out there. So for instance, for a number of building blocks, we heavily rely on what Sebastian just presented, coming from the IDS reference architecture model. But at the same time, we're also using technologies and standards coming from other areas too. And finally, we provide in the blueprint material for further reading. So if you want to know more, we refer to other documents. Next to the blueprint, we also have a glossary. And I think it's also worthwhile in the context of PLIADES to take a look at this. And it might seem a bit trivial, why do you need a glossary? But we've seen that in many dataspace initiatives, some common terms are actually lacking or are used in different ways, like a dataspace governance authority. It's called in many different ways. People have different understandings about this. And we said it is important, if we want to have common specifications, also to have a common glossary that contains the key terms in a dataspace. And I would also recommend PLIADES project to take a look at this glossary and reuse it where possible. It's low-hanging fruit. Now, zooming into the building blocks itself. As I said, we have both organizational, business, and technical building blocks. And compared to OpenDI, we have greatly extended the number of business and organizational building blocks, as you can see here in this picture. Now, if I zoom into those business and organizational building blocks, we've categorized them in 3 areas: business, governance, and legal. In business, it is really about all the financial and organizational part that you have. Why do you set up this data space? How do organizations earn money? How do you cover the costs? What are the use cases that are supported by this data space? And it also links to 2 important concepts, a data product and also the data space intermediary, because compared to, let's say, EDI or centralized cloud approaches, very often in a data space, there is some form of intermediary. That could be an intermediary as is indicated under the Data Governance Act, but also other forms of intermediaries are possible. And it is very important to think about that when you start a data space. And maybe certain technological approaches will change this. So this is the first pillar. The second pillar is about governance. So if you've decided, okay, this is what my data space is about, this is how I earn money, this is how I cover the cost, these are the kinds of use cases that I support, then how will you actually govern this data space? For instance, this data space governance authority, what kind of legal form will it have? What kind of links will it have to participants of the data space? Who can influence this? This is the second pillar. And then the third pillar, and this is the legal one, essentially with 2 views. One on the regulatory compliance, which is important given all the new legislation that was introduced. And the other one is the contractual framework. So what kind of legal agreements are there between all the participants in the data space And this is very important. We very often see people just looking into the technical side of data usage control and trust, but it should also be reflected in the legal side. And this is an important link to make. And in our project, like here in PLIADES, we have, for instance, the University of Leuven that plays a very important role in this pillar. As I said, the blueprint is evolving. So here are some of the highlights, especially for those of you who are already familiar with the 0.5 version that we've launched last year. The main message I would like to give here is that for each of those business building blocks and organizational building blocks, we are continuously providing more details, but more importantly, also practical guidelines. So for instance, there is a decision tree on the organizational form of your Dataspace governance authority that you can use to take the decision. Should it be a foundation? Is it a company, or whatever form should it be? So that's the business and organizational side. Then, of course, we also have the technical side. And on the technical side, we have divided building blocks into 3 categories: data interoperability, data sovereignty and trust, and data value creation enablers. So starting with data interoperability, there it is really about semantics. And well, Sebastian already mentioned that this is an important topic for him. It is an important topic for many data spaces, because this is something you need to agree upon. What are your semantic models? How do you create a vocabulary? How do you maintain this vocabulary? How do you link this to, for instance, an API through which you actually exchange the data? And also this is actually one we introduced in the latest version. How do you deal with provenance and traceability? So you're exchanging data, but maybe you want to keep a record of what you have exchanged for future accountability and traceability purposes. We've introduced this building block, but this is still a little bit terra incognita, I would say. There are different approaches here, and maybe the PLIADES project can actually help us to extend this topic with new ways of implementing this. Then in the second pillar, data sovereignty and trust, we introduced major concepts like verifiable credentials and SSI for doing identity and attestation management. I think in the next presentation we will see a bit more about that. We highlight the role of trust frameworks. So we know that you indicate that you're this organization, you adhere to those criteria, etc., but we should also have a role in the ecosystem that says this is true. So yes, you are on the very basic level a member of this data space, and this could imply that you have signed certain contracts. So here you also have the link between the technical concept of using SSI and the legal constructs that we have on the green side of our blueprint. And finally, and also Sebastian mentioned this, we advocate the use of ODRL for specifying and also implementing access and usage policies. Then in the third pillar, it's about data value creation, which has 2 sides. One is really about being able to publish data or expose data in a data space and make it findable for others. Here we heavily rely on the DCAT standard, which is also now part of the Dataspace protocol. And we advocate to use that in all those common European data spaces. And we've introduced the so-called value-added services. So you can imagine that there's data being exchanged in this data space, but there can also be some joint facilities, for instance, for supply chain visibility or to set up a marketplace or other kinds of shared approaches that you have in your data space that are being offered by the Dataspace Governance Authority or by another participant in the data space. And especially if you talk about things like AI and model repositories, this could be quite important. And we've now introduced a couple of approaches here, but I really want to see this extended as we move on. And again, this is also an area where we're looking at projects like PLIADES to contribute to this with examples and new approaches. Now, time is too short to go into all the details of this. I will provide you a pointer to the website where you can find more information, but there are a couple of slides. First of all, a building block is not a software implementation. So this is often misunderstood. People think, oh, a building block, that's like a piece of software that I can use. No, it's about the capability. And together, some of these capabilities can be implemented in a piece of software. Now, in the blueprint, we introduced certain categories of software. One category is what we call in the blueprint a participant agent, but I think in the context of PLIADES and the IDSA, this is often called a connector. So a piece of software that an organization needs to join a dataspace and to implement both the control plane and the data plane. And there you find things such as a participant wallet, a catalog of data, services, and offerings, where you do your contract negotiation, and at the end of the day also have your transfer process. So this is one category of software. And then a second category of software, I put it here under the umbrella of shared services. In the blueprint, we've detailed it a little bit. But these are the kinds of things that you need as a common enabler in your dataspace environment. So maybe you need to have a vocabulary hub to exchange your data models and to manage your data models that can be then used by all the participants in the dataspace. Maybe you need to have a participants register, which could also be a wallet again, that verifies whether or not an organization is actually a participant of the dataspace. And for compliance purposes, you might need to have an authorization services that keeps a register of transactions that have taken place, if that's of course part of the model of your dataspace. So it will be interesting to see how also the services to be developed in PLIADES fit into this picture. One area where we are looking at is the Simple initiative, which I think many of you have heard about. This is an initiative which is running next to the Dataspace Support Center of the European Commission, whereby they aim to simply procure software. And we are currently aligning with the Simple initiative to make sure that the software that is procured is also falling into those categories. To sum up, how do you now use this blueprint in a particular initiative? For that, we provide what we call a co-creation method. And I won't go into all the details of this method, but it is a step-by-step approach to work with a group of stakeholders to align on everything that you need to get your dataspace going. And in this process, we continuously refer to the specifications that we have provided in the blueprint. As you can see over here. So for each of the steps in this method, we have identified, okay, these are the building blocks that you need to consult. And then for each of the building blocks, we identify certain core design choices, so questions that you need to raise. In this particular example, identity and attestation management, here you see a couple of questions, but I also would like to refer to the next presentation where we have a bit more on that. Finally, I would like to wrap up here and send this message. Please connect, use, and contribute to this blueprint. It is a common initiative. It is publicly available, so you can go to our website and use it. It is also mandatory to use it for those common European data spaces through different ways. So it's not that there's a law that states it, but sometimes it is through funding criteria or otherwise. But we heavily recommend using it. Of course, there can be situations where you say, okay, but I have a specific situation where I need to use something else. Well, that's possible. Or, and that's actually even more interesting, if you have an addition to this blueprint. We will have future versions of this blueprint. So we also invite you to contribute to it. And if you have some interesting project results, we can also incorporate that potentially in future versions of this blueprint and make it then also available to this wide community of data spaces in Europe. And this is, by the way, the link where you can find everything. If you haven't done so yet, please subscribe to the newsletter of the DSSC. We're organizing a yearly event. We have several insight seminars, online webinars. And we can also directly support initiatives that require it. If you go to the website www.dssc.eu and you click on DSSC offers, that's where you will find the blueprint and all other accompanying documents. I think with that, Silvia, I would like to hand it over back to you.
Thank you, Matthijs, for insightful presentation about the Dataspace Support Center. Very important to consider, and we will investigate if we can be part of the community of practice, and of course, review the blueprint and get insights. Okay.
Yeah. And maybe to say one thing, I think particularly everything that is mentioned here in the project plan on federations, on AI, I think these can be really interesting additions to what we currently have there. So I think it's very important to have this link to projects such as PLIADES. Yeah.
Okay, let's talk it in separately, okay, and how to make it. We are just starting, so yeah.
I know.
Thank you, and we have Simon in our consortium, so the connections are well established. Okay, so now you have heard about Sebastian, and also Matthijs has explained, talk about data interoperability, data spaces interoperability. The data interoperability and data spaces interoperability is key in order to implement the data spaces and to achieve sovereign data sharing. So, and as Sebastian presented, the data space protocol is very important, okay, in order to achieve this technical interoperability. For that, I will ask Sebastian to jump in again and explain us a little bit in details about data spaces interoperability and about data space protocol. And after your presentation, we can continue with questions for all the presenters. Unfortunately, Ilknur has left us, but we have Sebastian here, and also Ilknur has left on the chat the contacts if you want to ask her directly. The floor is yours, Sebastian. Thank you.
Yeah, thanks again. And it's not only me, it's also you, Silvia. We also have you for answering questions and supporting. So, interoperability and data space protocol. Matthijs had a couple of words on interoperability. I also had a couple of words on interoperability in my first presentation on the reference architecture model. But now let's make it a little bit more practical. What do we talk about interoperability and what is really needed? And I would like to take the example of the data space protocol here to explain this a little bit in more detail. So I mentioned before, so we started back in 2015, 2016, and interoperability is a key aspect to be interoperable between the different partners, participants in a data space, meaning that their systems need to connect to each other, being interoperable. And well, how do you achieve that in the end? What we see is that we have a growing number of connectors, of data connectors available and in use. But how can we ensure that those connectors are in the end interoperable to each and every extent? And so one of the answers is a data space protocol. It's not the only answer, but one important aspect. We realized, well, we can measure interoperability to a certain extent, but a very clear specification is missing in the end that two partners can implement. And then the components will be interoperable, at least with regards to the data space protocol in the end. That was the key driver, more or less. And this topic came up roughly 2 years ago when we realized, well, we have something, but what we have is not sufficient. And then we started a lengthy set of sessions. So we've been working, as said, roughly 2 years to get a very clear specification for the data space protocol. And this is what we have. So we have released the version 1, 2024-1 is our stable final version of the data space protocol as is. But when we talk about interoperability, I like to reference this one because, well, there are other figures as well. I like this one because it has layers. We can also take a look at ISO IEC 19941, which uses a circle and so on. But it is important to, to understand And interoperability comes up on different levels. So we need it on a technical level so that the systems can really talk to each other, exchange data. On semantic level, you understand what kind of data you have, and there are great examples why this is important. We need interoperability on organizational level. You know that we have organizations that want to interact with each other on level of the business processes. So we have to be interoperable on that level, on organizational level. And we need a legal interoperability level. So a common framework, a legal common framework that we can use may be based on contracts or may be based on regulations that exist. This is a little bit the field, and what we see is that especially those technical and semantic level interoperability parts are really things that a participant has to take care about more or less with implementing in the connector. While organizational interoperability and legal interoperability is more or less managed on the level of a data space, so by a data space governance authority, by the rules that we have inside a data space. Both more or less, of course, this is not a very sharp distinction, but at least along those lines. And then we have to distinguish between how can we interoperable in our data space, in our domain, but how can we also connect between different data spaces, so inter or cross data space interoperability. Especially from the perspective of me as a participant. Most organizations are not active only in one domain. You're typically connected to multiple domains. You're manufacturing, but you also do logistics because your parts have to be delivered somewhere. Sometimes you're also into finance, into insurance, and also on. So different domains needs to be addressed. And how can I ensure that I can easily connect to those different domains? That is an important question when it comes to interoperability in the end. That didn't work. So when we talk about those different 4 levels, then for the technical level, we talk a lot about connectors, about component frameworks, about the data space protocol. That is one part of interoperability at a technical level. Let's say one part, and I will come back to the point where the other part comes up. Dealing with semantics, which is sometimes also part of the data space authority policies, so to mandate, for example, a certain domain model or not. But you have to deal with typically semantic models on different levels. May it be describing a data asset, a data product, may it be describing a policy so that is interoperable and understandable, or may it be the data itself. How to get an organizational setup. This is more or less covered in the rulebook, in the IDSA rulebook, but also in other rulebooks. And this is also, coming back to Matthijs' presentation, a task of the DSSC to work on a rulebook toolbox, so something that could given to the hand of the data spaces to come up with a set of agreement. Then of course, the legal aspects, which is also part of IDSA, where we have our task force legal framework that is discussing such topics on legal level as well. But in the data space protocol, let me explain a little bit. So what you will find inside the data space protocol and why it is important for interoperability in data spaces. We define 3 parts inside this protocol. So 3 different protocols combined into one protocol specification. One is a catalog protocol. So how can you create and publish a data asset, something that is tradable, exchangeable. So it relies on the reuse of DCAT. And we, of course, describe, so what are the messages that you need to exchange? So how is the interaction in general? And what are the messages that need to be exchanged? What we do in general in the data space protocol is that we have a structure. So describing, so what are the messages that need to be described? What are the state machines for the interactions? That is a basic setting. And then we bind this specification to tangible API bindings. What we have is a REST-based API binding that you can use, but you can use also any other binding. Bind this to an MQTT protocol or gRPC, whatever you like. And that's not part of the specification, but possible. That is one part of the further extension of the data space protocol to add new bindings if required. So catalog protocol, this describes those different messages. So I can request some catalog information from you. So what are the data sets that you're offering and so on. Then after you have published and discovered such a data catalog, then we want to step into this contract negotiation part that I explained before. And after we've agreed on a contract, then you want to step into the transfer process. And so the Dataspace protocol does not implement the data transfer, it does manage the data transfer. That means that the Dataspace protocol gives you some measures after we have agreed on a contract, that afterwards I, as a data provider, can inform you, well, your data set is available. Now you can fetch it, because I need to spin up a virtual machine for that. I need to do some preparation on the data, whatever. So it may take some time between I have agreed on a contract and the resources are really available for consumption. That is managed, and then the continuous data exchange, including a suspension, for example. And as a Dataspace protocol is here with that regard not a wire protocol, it does not manage the and suspend the data exchange if I unplug the network cable or Wi-Fi is down, things like this. But on a more business level, you didn't pay the invoice. You're not trustworthy anymore because you had a security breach, whatever. Then I can suspend the data exchange and resume it afterwards. That is a little bit the difference and the scope of the Dataspace protocol. So, as explained before, so those are different parts, what will happen, what is a problem. So I leave this to you for further reading afterwards. And this is basically the structure. So we distinguish, I mentioned that before, between the parts on the control plane, which is very generic and usable in each and every data space in the end, because, well, that's what you have to do. You have to publish your data set. You have to discover data sets, then you need to agree on any kind of contract, may it be in a negotiation or just take it or leave it, and then manage the data transfer. And the data transfer itself is done in so-called data planes. So in a different phase, but also in those different data planes that should be reusable in the end, because they implement parts like, well, this is a wire protocol that we use. We are going to have a REST-based approach. We are using classical SOAP web services. We have a streaming API where I continuously stream something or have something that is more or less event-based. Those things are implemented in the data planes. So including technical interoperability part, so there's a wire protocol, implementing the semantic part, so this is a data model, the messages that we are going to use to exchange the data, and they also can implement requirements towards usage policy enforcement. So I am here in this domain, this is the wire protocol that we use, this is the semantic model that we use, and we typically have those rights and obligations on data, so we have to implement something that data cannot be forwarded, must be deleted after a certain amount of time, must be processed in any kind of encrypted enclave or whatever. So those things are part of the data planes. So those data plane projects, we see them at the moment developing and popping up. And so this is a subject of future work, to come up with a great catalog of reusable data planes that you can use inside your domain and inside your use cases. But as I said, the Dataspace protocol deals with cross or inter-data space interoperability and interoperability in a data space when it comes to the control plane, the reusable concepts. The data planes, they are not part of the Dataspace protocol and therefore need to be built or specified and built afterwards, and shall also be reusable. So, and both aspects solve the issue of technical and semantic interoperability to a certain extent. I think I described this already so far, what the different points are. A little bit our way forward with the Dataspace protocol. And I know that this figure is a little bit complex. So this is basically the idea of the Eclipse specification project. So we are at the moment starting to have a new Eclipse project for the Dataspace protocol, because the document, the specification document, as said, is finalized. It is available by IDSA, and we are filling this one into an Eclipse specification project. To have this one, it will be complemented, and this is ongoing work with some technical artifact, in this case a TCK, so a technology compatibility kit. In the end, that's just a bunch of JUnit tests, a couple of test cases where you can test against, so is your given implementation compliant to the Dataspace protocol specification document? And this is our task at hand at the moment. We have the specification document finalized. Now we can write all the test cases, bundle them in the TCK so that you can validate, well, this component is compliant to the given specification, which can be used in a certification approach, so by a third-party assessment, but also in your CI/CD pipeline, so that you can continuously measure if your component is already or still compliant to the Dataspace protocol during your developments and deployment. And then it will be complemented with a so-called compatible implementation, at least one compatible implementation. At the moment, we have Eclipse Dataspace Components, EDC, as a first compatible implementation. But I mentioned before, we have with the data connector report a list of roughly 30 connectors that are working into this direction to be compliant to the Dataspace protocol. We need at least one compatible implementation. We want multiple compatible implementation because once we have combined that, we have a final specification document, we have the final TCK that measures compliance, and we have at least one compatible implementation. Then this will be one final specification under the terms of this Eclipse specification project. So this is really something stable that is usable and that can be really used as a reliable basis for a couple of years. It will not change every now and then. Of course, we as IDSA will continue working on it. There will be a new version of the Dataspace protocol somewhere in the future, but you will have a final and stable release version 1 that you can test against and that you can use as a reliable basis in real industrial projects. And especially when we talk here inside research project, the question is more, so not only what is reliable, what can we use during the project lifetime, but also what can we add on top of that? What are new things that can be added on that one? And there IDSA is the right partner. We will continuously work on new versions for the specification document and then follow up with all the other projects to come up with a version 2 of the Dataspace protocol in the future if required. We have a couple of partners working on it. So we have our pretty small group at the moment of real active contributors to the Dataspace protocol. So those are the main contributors coming from SAP, from Microsoft, from Fraunhofer IVI, TNO that have been really doing the heavy lifting, and a couple of more IDSA members that have been supporting. But really would like to give those 5 a floor because, well, they did really the heavy lifting on that one. We have a couple of users. Like Catena X, Techniker is building, so we have to fill this list a little bit more. So I have the gut feeling there are more. And well, maybe I can add the PLIADES project also as an R&D project, adopting the Dataspace protocol here in this slide in the future. You can, of course, be of help in the future work. Of course, feel free to join us and become a co-creator of the Dataspace protocol. We warmly invite you to check the specification document and see so if there are things that need to be changed, that needs to be adapted, that needs to be moved forward. I mean, we have at the moment 3 core protocols in the Dataspace protocol. Maybe we are missing a 4th one, an observability protocol, for example, which is at the moment under discussion. And of course, we always need support in implementing projects. So build data planes, build Dataspace protocol connectors, but also support us in the development of the test of the technology compatibility kit. Always help as needed in those open source projects. A little bit of some hot topics. So we are reviewing at the moment a little bit how the Dataspace protocol can connect to the IDS information model as part of the RAM work, but also compatibility with the FAIR digital object, which is also from the research perspective a very interesting thing. Brings things closer to the underlying W3C specifications and so on and so forth. So feel free to join us. You will find all the things in the GitHub repositories. So just feel free to use it. It is there. And I would like to briefly switch to one thing because that's my baby. I'm really proud of it. Well, this is a beautiful version of the document with my typical black background. So this is a specification text, but you will not only find text specifications here. Of course, you will have, and I mentioned that, you saw that before, so such state machines where you can understand how the interactions work, when which message will be sent out and how they are structured. But you will also, so not only for the contract negotiation, also for the data, for the transfer, the relevant text and images are provided. But you will also find all the required JSON files. So the schema files are all available likewise via let me switch back to this one via docs.internationaldataSpaces.org. You will find the specification document, or you follow us on GitHub. And then within our IDS association, the IDS specification project, where you can find all the different kind of schemes that you will need to implement your messages to implement the Dataspace protocol. All available under the Apache 2 license, free to use. And as mentioned before, if you have something that you would like to comment, that you would like to add, feel free to raise an issue here and start collaborating with us. Thanks.
Thank you, Sebastian. Very interesting and very useful for our purpose. And thank you for the recommendations to join the Dataspace protocol community. And now we have some minutes for questions. So please open your mics and ask questions if you have, in order to make it interactive. Any questions? Comments? Yeah, Marco, please.
Yes, good morning, everyone. I have a question with regards to the implementation of connectors. Is that you said that whereas you explain your guidelines, but are there existing examples to take inspiration from? Maybe understand how to move with this towards these connectors? Thank you.
Yeah, Sebastian, of course.
Yeah, if I may take the answer. Yes, there are multiple. So my recommendation would be, as a good starting point, check the data connector report that you will find on the IDSA homepage. There you have a long list of existing implementations, and basically you will find 4 different things. Let me take it like this. The first one is something that is relying on the so-called Dataspace connector, which is, let me say it like this, maybe the old implementation. It is not up to date with all the latest developments, but this is a very interesting implementation because it's pretty straightforward how you can easily implement a connector based on existing technologies. So as said, it is not completely up to date technology-wise, but it's a good learning example and available as open source. Then we have everything that is based on the Eclipse Dataspace components. I said before, that's not a connector per se, because it's missing some data planes, but it's a good foundation, a framework to start connector development. This is a good starting point with the EDC. And then projects that are reusing EDC, like TractorSX, for example, which is also an open source project, also a good way of learning. But EDC, well, that's sophisticated software engineering. It's not too easy to understand how it works, but it's definitely a good implementation. The third path is in the directions of FIWare. So we have some FIWare-based connectors as well. For example, engineering maintains a so-called True connector, which is also available as open source, and a good starting point because, well, dealing with this FIWare context broker works slightly differently than in EDC, for example, where you use different mechanisms for message routing, but also a good starting point to understand how those people are implementing things. And then the fourth category is, well, everything else. We have a couple of other implementations that approach it from other paths. Some are open source, not all are open source, but there are a couple of good starting points. There's open source project that you can download, study, make them run and understand if they are useful for you or not. So this would be my recommendation. There are a couple of good starting points, but all those things are differently. So it also depends on what do you want to implement exactly, what are your constraints. But as said, there are a couple of good illustrative examples at least, and usable components as well that you can directly use to get started.
Thank you.
Okay,
Sebastian.
thank you. Thank you.
More questions? Yes. Frank, please.
Yes, sure. I have a question to Sebastian. Thank you very much for the very, very professional talk. How often did you hold it already?
Which one? For the
I don't know, the
reference
first one. It was both very good.
Yeah, I'm doing that for 7 years.
Oh, yeah, okay.
So not RAM 4, but RAM 1, RAM 2, RAM 3. So.
Oh my God.
I'm used to it.
Yeah, it shows. I have a technical question as well. Is there some sort of stripped down version that we could use instead of a full Dataspace implementation? like, is there something we can leave off? I mean, it's a very complex field, but what is the minimal thing that we could do in PLIADES, in, for example, mobility data spaces?
I cannot answer this, and I'll tell you why. Because this is your job to understand that what are the key aspects that you have to understand and that you want to implement in your research project. Because, well, you're a research project and not targeting full industrial implementation. That means, of course, you can strip down some relevant aspects where I typically say, oh, you want to have an industrial data space, you need to consider all those things. But what is typically really required is that you focus on the aspect of the data exchange and data sharing. So those core mechanisms. I would really recommend that important for you is, first of all, this interoperability aspect. So how can you offer and exchange data in the end? I mentioned this usage policy negotiation thing. Well, you can strip it down and say, well, we just have one typical standard usage contract here with 2 rules. And that's all, because we don't want to dig into usage policy enforcement, for example. Just use a standard contract and then you're good to go. Don't take too much time for that. If you think about the trust framework, for example, you can leave it to some points because, well, the key aspect in the end is, well, you need to have some claims. You need some identity and you need a claim in the end. And then you have to understand what is important content in such kind of a claim. But don't make it over sophisticated and think about complex trust frameworks. Of course, hey, that's cool. And if it's of interest for you, then please go ahead and do that. But that's something where you can say, okay, I limit it to the minimum and leave the rest to existing implementation. And what I would really recommend is the question of semantic interoperability. So what are really the mechanisms, the data that you want to share, and how do you describe it? Do you have something like a standard ontology that you want to use, a standard data set that is reusable, or do you have to describe each and every data set on its own because it's completely differently? Those are, for me, the key questions and aspects. And what you should definitely do is to do an analysis of your use cases, of your pilots, of your ecosystem. So what are really the interesting things to implement and to evaluate? Because each domain is differently. Sometimes you have very sophisticated concepts already in place. In tourism, there is a great ontology for tourism data. Hey, that's cool. Please don't reinvent it when you can use something that is there and under maintenance. So those are a little bit food for thoughts for you.
And when do we know that we are finished with analyzing our use cases? Because I mean, like, that's an open topic. You can go on and on and on.
So I would follow your gut feeling. This typical 80-20 rule. You're right. You can die in analyzing and doing things, but at some point of time you will say, so this is a good starting point. And it's always helpful to say, okay, this is the field of topics that we have. Here we have a good starting point, and those are questions where we have to consider it and make it something, be agile, be a little bit iterative, and see, so does this work? What is the minimum things that you want to achieve? What goes on top of that? That helps you to structure your project a little bit. That would be my recommendation. But of course, it's up to you inside the project how you structure. And honestly, I haven't read the whole PLIADES proposal and do not exactly know what you're up to. Otherwise, I could give maybe a little bit better guidance.
Okay, thank you very much.
If I can elaborate a little further on the question of Frank, one limitation we have in PLIADES is for the use cases we have a limited number of stakeholders because they're within the consortium, so we can have from 2 to 5, let's say at the most, stakeholders that produce data, they might require data, etc. With this limitation in mind, what is the best approach when we start to design the data space?
So as said, you should reduce it then if you only have a couple of stakeholders. Then a lot of questions that come from the trust framework are really not really relevant, especially because you know each other, you have a frame contract here in this, so you need a foundation, period, and that's easy to implement. Then the second question is, what kind of data do you want to exchange and how do you describe it? And what is the value generating process out of it? So what is really the key aspects of the data that you need? So into this direction. So, but if you only have such a small group, then a lot of questions, how to build a data space governance authority, how to do some maintenance and all those things. Well, that's not maybe too important.
That's clear, thanks. And a lot of things that we will develop would be AI tools for crossing the data, having machine learning models, etc. This would be in the form of apps. What do you think could be the best way to include them? Because you mentioned in your presentations about apps and app providers. Are there Dataspace specific apps? So they're developed for specific data spaces, and they are, let's say, known to all the users of the data spaces that these apps exist and we can use them. This is the idea of the apps.
Yeah, so both. So apps can maybe serve three different things. So you can have really super generic apps that can be used in each and every data space. Just think of typical ETL tools that you will need basically everywhere. So this could be an app that you can easily ingest data from a data source, transform it, and put it into any kind of system. So this is super generic and something that can be used in each and every data space. Then you will have specific apps for specific domains. Just consider, I don't know, if we talk about an energy data space with wind turbines, some kind of weather data management, when do we have gusts and such things. So this would be very domain specific and reusable there. And then you have really specific apps that you want to just use for your own use case, really super use case specific. So this is a little bit the dimension here that we have with the different kind of apps. So this is something that you could consider as important, especially for AI things. There is one other aspect when you talk about AI, which at least from my perspective, I see at least as interesting, and I think you're more advanced in this topic than I am, but we will publish a paper in the next week. So it's finalized. It will be from the press next week on the relationship between data spaces and the standardization request for the AI Act, because there are a couple of requirements that you have towards AI in the European Union based on the AI Act. And the standardization request has some very important aspects, and you will not resolve everything with a data space, but two concepts or two requests are very interesting, and I think this is something where you can connect it with a data space. This is especially the part of the data governance and the data quality, because this is what you want to achieve. You want to have from a provider of the data that you want to use inside your AI models, you want to have a certain degree of quality. This is what you want to have. And then you want to have an assurance that the provider did his or her job well and provides data in a good quality. So you could have some measures for that. So think about that, what kind of measures you could have, and how can you put a stamp on that? So yes, I did my job well, and I put a stamp on that so that you as a consumer and building AI models can have also a good traceability. So where was my model poisoned? Where came the bad data from, and so on. And so this data quality and how to adapt those governance mechanisms, which is not only technology, but sometimes also just management processes. So this would be for me also a very interesting question to answer. I don't know exactly if it fits to your work, but
it fits perfectly. We have already a lot of research tasks on the data quality assurance and evaluation. There is an aspect where we investigate about the quality for use them for machine learning and AI applications with data. So I think we can explore for sure on that direction that you suggest. I had a lot of questions, but let's wrap it up with the final one about the vocabulary. You mentioned about publishing vocabularies, that we can use existing vocabularies, that we can create our own. If a vocabulary it's 90% perfect for us, but we need to extend it a little bit, this will be considered a new vocabulary, or we are free to modify existing vocabulary?
So it depends on the license of the existing vocabulary, if you're free to extend it or to change it. That's a licensing problem. So, and let me make here two important things. So the technical issue with the vocabularies, well, that's easy. You need a vocabulary, you need to create it somehow, and as you rightly say, you have a vocabulary that has 90% fit. You will change something, you will add something, you'll combine two vocabularies, and then you're good to go. And that is a technical process. And then with a vocabulary hub, you just want to publish it somewhere. And so if this is not your core task, then well, put it on GitHub, render it via GitHub pages as downloadable thing, and then off you go. That's really super easy. That's the technical part. And what is typically sufficient for a research project is getting interesting when your project ends. You know, who will maintain this vocabulary, and also during the lifetime. So what happens if one of your friends here in the consortium just changes something inside the vocabulary in month 32 or something, and then all your pipelines fail because, well, the name of the attribute was changed. That is a real issue that we have at the moment, how to create a governance and the maintenance for all those vocabulary. Technically, it's easy. You have to agree on something, and that is the concept that I explained. You're in a data space, and then you agree those are the vocabularies that we want to use, and you agree on such maintenance models that you update accordingly, that you have some time to implement changes and so on. But that's a governance process. You can have it very limited inside the research project because you're a couple of people working together. When you talk about real industrial data spaces, where an industry relies on such a vocabulary, then you want to have a stronger governance that you can do a good updating and maintenance mechanism so that the data supply chains will not fail.
Thanks for the heads up. Yes, it's very crucial, I understand. That's all from me. I give the floor to other people for questions.
We are running out of the time, but we have last question from Angelo, please. Angelo.
Yes, I will try to be really brief. Just Sebastian, hello everyone. I want to connect to the comment from Frank when he was asking about how to start. Indeed, looking at the question, I was thinking of the concept of the minimal valuable data space into the testbed. So the question for you, Sebastian, if you have already a plan also how to update this concept and the testbed, I would say as an artifact, to the new RAM 5 or to the Dataspace protocol?
If we plan to have something like an updated or new testbed, the minimum viable data space is a question. Yes, of course. Of course.
In fact, I asked about the plan, so yeah. I was sure.
Yeah, that's good that you ask about the plan and not about the reality. Of course, and I want to mention again, so IDSA, we are not building software, so we will not provide an IDSA developed testbed minimum viable data space that all of you can use. So that is not our mission, that is not our job. But we have this good overview, and we have assembled the first IDS testbed as a minimum starting point to show, well, you can build a data space. This is a good starting point, how to start building data spaces. This will be extended this path. So we have an ongoing development with the so-called Basecamp, which is a foundational set of components that you can use to build a data space, which are in industrial practice already and available as open source. So it's not coming from IDSA, but that's a good development as a starting point. And the plan is also, well, we look a little bit into the direction of Simple. That Simple will provide some open source components. I hope, and that is a plan, that they're fully compliant to our work in IDSA, but those plans tend to break at some point of time because it's not under our control what the Simple consortium will implement. But this is a plan that the Simple project will provide open source components that are compliant to the IDS specifications that you can use, and you have things like the Basecamp from industrial practice. We would have Simple, and we see that also a lot of components are developed in other directions. I mentioned the EDC, for example, and the Tractus-X implementation. From EDC, there is also a minimum viable data space, a starting point to implement things. With the Catena-X initiative, we have some good starting points. I could also reference to the Smart Connected Suppliers Network, which are providing some open source components that are used. So our job is to provide multiple starting points because things are differently. And by the way, we can also talk about a true-based minimum viable data space, which is also somehow available. So there are multiple things. Our job is now to align things, to make sure that all those different test beds are somehow interoperable and compliant to each other and serve all the different directions that are needed. So we have a plan to connect all those different things to each other. That's the plan. Let us discuss about the reality in 3 years from here or so, if this plan worked out or not.
Okay, really, thanks.
And so we need to continue. I am going to explain you what is next, and then, for who is. In this second part, we are going to focus more on the use case because we have projects that have already started working on implementing data spaces in different sectors. And we are going to see what is happening in energy sector, manufacturing, healthcare, and mobility. You can see the speakers for each slot. But first, I would like to give the floor to Carlos. Carlos, are you here? Okay, perfect. So Carlos, please, I will appreciate if you can explain us the radar and how we can know more about the available data space use cases pilots. Please, Carlos.
Yeah. Hello, good morning, good afternoon, everyone. Thank you very much, Silvia, for inviting me. Really nice opportunity to be here. I will try to make it quick since I see we're a bit over time already, and we have so many interesting topics ahead of this one, but yeah, I'll try to make it quick, but to be concise. So just 1 second while my full screen loads. Yeah, so hello everyone, here Carlos from the Impact team of IDSA, happy to share with you a bit more about the Dataspaces radar, hopefully the home of your of the future use cases, IDS-based use cases from the PLIADES project. So yeah, the radar is one of our most valuable tools here at IDSA. And the idea of having this Dataspaces radar is that IDSA has been building the assets for Dataspaces for the IDS standard and promoting this since 2016. So since we started back then, developing our assets, since we started promoting Dataspaces, many use cases have been started adopting this standard, and we see more and more impact stories. But we need a place to visualize all of this. So in the very beginning of IDSA, we had a couple of impact stories already, but now we see that every day we get more and more use cases adopting what we bring to the table, so our technology, our concepts, and we really need to have a place to give this transparency for many reasons. So this is why we decided to come up with the Dataspaces radar. Here, as you can see in the slide, this is a place where you can find all of these implementations sorted in different domains. So we can find examples on energy, on health, on automotive, many other domains, and also you can find them according to their development stage. So going from the starting outer circles of the radar and the starting phases of a use case, just exploring what's out there, all the way to the center of the radar with live market-ready implementations. The idea of the radar is also not only to bring transparency to what's out there, what technologies are being adopted, but also to serve as a source of inspiration. So maybe you have an organization and you are sitting on a huge amount of data, and you don't really know the way you can unlock the full potential of this data. So it's also a good idea to have a look at the other use cases on the radar and get some inspiration of how others are already implementing this, in which way they're sharing their data. And if you don't want to really come up with your own use case, you can also join another existing Dataspace endeavors. This is also another third use of the radar, so to see what's out there and use it as a starting point for matchmaking. So you can visit the radar via this link on the slide, and I will also share the link in the chat. So also happy to share with you that a couple months ago we inaugurated the new version of the radar. So it's based on what we had starting from a couple of years ago, but we can find new features here. So we can see that the new radar has a very improved user experience. You can spend hours looking at the Dataspace example there, and it's easier for you as a user. We have an increased capacity, so now we can welcome even more and more Dataspaces to the radar and still preserve this really top-level user experience. We have an enhanced visualization, and I will quickly go through the different views that the radar has to offer to make the information more accessible to you, more digestible. We have an advanced filtering feature, so we have many more ways to visualize this information, different filters. We have also a global reach, so we're welcoming more and more use cases from different parts of the world to the radar, and we are mapping this endeavor so you can see where Dataspaces are being adopted. And technical transparency. So we have a special view for the technologies that are being adopted for the radar in the different use cases, and you can also have access to it. So quickly, first we have our classic view of the radar. Here you can find the different data spaces, the different use cases, and also parts of the community of practice here. And you can just roll through the different domains and look for these different entries. But then we have this new, one of the new offerings of the radar, the chart view. So you can have a look at how the radar has been growing over the years, new listings on the radar, which reference architecture they are adopting, which data connector they have, source of funding, and many other information that can be useful for you. You can also have a look at the map view and see where data spaces are being adopted. So as you can see, we're practically gaining more and more territory. We have use cases in Japan, China, North America, and many more to come. You can also have the classic table view if you would like to access it in this more discrete way and have an easier way to arrange the information. And finally, we have the building blocks view, where you can see which technical building blocks are being adopted in each use case, and you can also see what technology belongs to each building block. So this definitely brings you a broader overview of the information on each use case. But what can you find on the radar? We're happy to share with you that we already have nearly 160 entries on the radar. 77 of them are use cases, and 82 of them are data spaces spread across different domains. So I would like to call you to action to please explore the radar, go through it, have fun looking at the different information, getting inspired on use cases. And hopefully, once we have some new use cases from the PLIADES project, it will be great to have them on the radar. So you can also follow this QR code, or you can also follow the link that I will put in the chat to register your use cases. You can do so via a job form. It only takes about 10 minutes, and then you are in the radar. And before ending my presentation, also, I would like to quickly share with you that IDSA is open. It's opening its ecosystem building call from the month of May, and the first call in June. So from May 6th to June 3rd. This ecosystem building call is a weekly touch point that we have where all of our members gather and share their data space endeavors, but also get updated on the latest news from the IDSA head office. This is exclusive for members, but for this period, we're opening it to anyone who's interested. You only have to register via a short form that I will also share in the description. And please, feel free to share this, to spread the word, and get as many people as possible from your networks participating in this open month. You can find more information on the website. And I think it's a bit of their time, but thanks for your attention. And happy to answer any questions in the chat.
Thank you, Carlos. Very interesting. And we hope that we can publish our pilots under PLIADES project. And next speaker is Sonia Jimenez, who will introduce us on the topic of energy data space interoperability framework. Welcome, Sonia, and please, the floor is yours.
Hi, thank you. Let me share my presentation. Yes, hi, everyone. I'm going to present the work of the energy data space cluster with regards to interoperability. So first, let me introduce you the energy cluster. So in the inner layer, you can see the first projects that started the cluster. Like 2 years ago. In the center, you have INNET, which is the CSA that gives support to these projects, DataSeller, EnerShare, AD Synergies, and OmegaX. And in the outer layer, you have the projects that recently started and joined the cluster. And the goal of the cluster is to prepare the ground for the common European energy data space. One of the things that the inner layer have in common, or one objective, is that they need to become interoperable among all of them. That means we need to achieve inter-data space interoperability. And to do so, we are working mainly on these 3 activities. So the first one is the position paper that we published back in October, which is the interoperability framework in energy data spaces. I'll give you an overview of this paper in this presentation. Then we are working on some business and system use cases, also with the goal of achieving this interdata space interoperability. So we've defined which business use cases are relevant that we need to cover for the energy domain. And with the system use cases, what we try is to define technically how we achieve this interdata space interoperability. And the recently published blueprint of the common energy, European energy data space. Here, this is also the common work of this cluster. And here we have, for instance, we defined a common architecture, reference architecture, that could be the basis for the upcoming common European energy data space. So starting with the position paper, this activity started a year ago. So we gathered some people from the different projects, and we said, okay, what does this mean that to be interoperable? So how do we achieve this interdata space interoperability? So we said, okay, we need to define a framework. So we gather all this knowledge in this paper. And the purpose is just to define this framework for achieving technical and semantic interoperability for the energy domain. And it uses as basis the work of this energy cluster. Contributors to the paper, so it's mainly the project coordinators and technical coordinators, then the semantic and technical interoperability task contributors from each project, standardization task leaders, and the pilots coordinators. As relevant initiatives, well, first, we structured the paper based on the new European interoperability framework on these 4 layers. And we use input from the blueprint, for instance, that was presented this morning, previously this morning. And also, of course, based on the reference architectures of the IDSA, FIWARE, and Gaia X. We described the current challenges of the energy domain and a lot of focusing on the digitalization that it's undergoing, and also the different rules and policies and guidelines that define this sector, and how we describe also how interoperability can solve and can help in these challenges. So key findings, very brief summary, the importance of standards to achieve interoperability. With regards to technical interoperability, we have some challenges, mainly because of the different connector services and trust frameworks that are developed, that are being used. So yeah, we describe what's needed to achieve technical interoperability. And with regards to semantic interoperability, the challenges we are facing are the different types of semantic models. So we need to harmonize ontologies and data models, and also find common vocabularies and data models. This is on the left-hand side, you have the current content of the first version that we published, where we describe the state-of-the-art and standards. We touch upon the topic of data space governance and interoperability. And we focus a lot on technical and semantic interoperability. We also mention existing interoperability tools and platforms, and we briefly describe how to achieve cross-domain interoperability. In the second iteration that we are currently working on, we add the aspect or the perspective of the actors of the energy domain, because we want to describe how this interoperability that we want to achieve has benefits for the different actors in the energy domain. We explain also organizational interoperability, so not only technical and semantic. We go one layer above. We describe the use cases that the cluster is defining, and we add one use case of cross-domain interoperability with the mobility domain. Now I'll briefly explain the system use cases and why they are important. So as I said, we need to achieve this interdata space interoperability, and we need to really make it happen. So we need to prove it, that not only we are describing a reference architecture, but we are defining exactly how this interoperability is achieved. And that's why we define 4 system use cases. And here we we rely on a minimum subset of software building blocks, APIs and interoperability standards, and the projects also commit to aligning their technologies and their reference architectures. And here you have an overview of the 4 system use cases that we defined, starting with onboarding. And this deals mainly with the type of identities that are used in every data space. So we're trying to harmonize those. The second step will be the data discovery and how to push metadata into the catalog. Then third use case with contracting. So once you're onboarded, you can search into the catalog. How does this contracting happen? And when these three use cases are complete, then data exchange can happen. So this is the end of my presentation.
Thank you, Sonia, and thank you for being straightforward on the time. And I think these system use cases are really interesting for our purpose and maybe inspiring. And now let's go into one of the key domains on PLIADES, that is manufacturing. And for that we have Angelo Marguglio, who was the responsible of developing the manufacturing dataspace blueprint under Dataspace 4.0. Welcome, Angelo, and thank you for coming.
Thank you, Silvia. Yes, I will go briefly through this presentation. Again, try to recap a bit the time. So first of all, I want to share the information that this work is dated back 6 or 9 months ago, when the first version of the blueprint from DSSC was not yet published, but obviously we started from the starter kit from the version 0.5 that was mentioned already this morning. The idea behind our work was to try to facilitate the understanding of the work that the DSSC is doing at a general cross-domain level, specifically for the manufacturing domain. So taking care of the different standards that are available for the manufacturing domain, which is already known to the manufacturing people, and this is why we are trying to anchor this blueprint to the RAMI 4.0 reference model, but also try to provide available implementation, available reference use cases, and also support the certification strategy. So it's a way to look with the manufacturing lenses to this general domain and cross-domain results from the DSSC. But the main ambition was to have concrete tools to support the design phase of a data space. That is more or less also what Gianni was mentioning in the question before. So which are the right question, how to address when I have a small list of stakeholders within a data value chain. So we are trying to provide some hints on how to answer, but again, the real value is analyze these answers within your ecosystem. We started obviously not from scratch, but identifying and studying a bit more, which was the challenges and opportunities landscape for the manufacturing domain. We defined some practice, the existing communities and code of conduct, as mentioned, the convergence toward manufacturing standards like RAMI 4.0, identifying specific building blocks and building a catalog of reference implementation for building blocks for the manufacturing domain, and then support also this creativity part of how to make the right question, how to design your data value journeys, how to ask about your business value journey, and how to certify what you are doing. So we'll try to go briefly between these 3 main pillars. On the be aware one, so the context, I will try to skip, but just to give you some highlights, you know, the data market is increasing, the data market for manufacturing is increasing. There are new challenges, especially due to the convergence between the OT and T technology. I think that it is more relevant for the manufacturing domain, and there is a complex and wide ecosystem that is pushing, has been already mentioned, OpenDI, the CC, the overall Dataspace Business Alliance that are working on the data space level. But on the manufacturing domain, there are other initiatives like Made in Europe, HEFRA, Connected Factory, the first and the second CSA that is pushing with pathway on how to support this digital transformation on our manufacturing companies. And there are already other parallel initiatives like Manufacturing Mix and the 2 funded projects for large deployment of manufacturing data space that are underpinned as smart tenants that has started obviously following the activity that has been started within our CSA, the Dataspace 4.0 project. As mentioned, plenty of opportunities, the connection between the operation technology and information technology. So obviously, I would say that the initial step moving forward also the adoption of Dataspace technology of the federation on that. But there are also a lot of new technologies, and the PLIADES project obviously will be mainly focused on the artificial intelligence, but indeed also the digital twins, the cognitive digital twins, there are where a lot of artificial intelligence is really can be embedded, is really posing new challenges. And again, I want to give a short answer to the comment from Yannis. I mean, the fact that you are really focusing on the technology side of providing AI tools. Indeed, you are in the right position, in the perfect position to give new hints to IDSA and to the DSA, to the DSSC, on how a technology provider developing AI-based tools for the broker, for the whatever, can really get some benefits. So probably you can provide new requirements for the overall Dataspace protocol, for the overall RAM 4.0, since you have a different perspective from many other end users that just want to use the Dataspace for their business value. Indeed, you want to create new business from the technology perspective. So again, your position, I think that is really well positioned to provide insights. Regarding manufacturing, I was mentioning about the connection. The net zero objectives is another big challenge for us. And again, how to master all this complexity. We want to be smart. Obviously, we want to adapt what is, I would say, cross-domain, reuse what is existing, again, at cross-domain level, but also the manufacturing domain. And we try to map all the different building blocks from the taxonomy of the DSSC to the different layers and usual, I would say, expectation from the RAMI 4.0 in order to make this more concrete, more understandable for a manufacturing expert. As mentioned, we have been collecting implementation, especially open source implementation of some building blocks that has been already validated in the manufacturing domain. Obviously, still not a complete catalog, but it's something that is evolving over time. And we want to support the creative part, so the design phase. This has been mentioned already this morning by Matthijs, has been mentioned by Sebastian. You need to create or to follow the right questions. So you have to start from the business strategy. So which is the value, which is the business value that you want to get out of this data exchange. You need to define and to agree within your ecosystem about the data strategies, especially when you look at the federation of different data space. We have to try to create a convergence between different data strategy and data management approaches. You have to select the right technologies. So the question from Yannis is exactly on how we can select the best technologies for us for validating this within your project. Then there are a set of available implementation building blocks that can be reused, extended, or you can contribute to. And then obviously you will define and implement your target solution. As mentioned by Matthijs in the starter kit, there is already a checklist. As mentioned, this is quite general purpose. In our blueprint, we have tried to detail a bit more this question, especially for the manufacturing domain. So in our blueprint, you will find some new questions or some specialization of the existing ones that can be used for Dataspace initiative that want to create or to join to a manufacturing data space. This is the last slide, I think, from my presentation that is about the value journey. Since exchanging data obviously is done mainly for the right new value for all the stakeholders that are involved. So we have defined here on the right-hand side, I would say, the data value. So we move from the data from the machine, from the operation technology, through the information technology. Then there are already available open data set that we can explore. We can access data from an available data marketplace. But the most important fact that we want to use a trusted network and federate a trusted ecosystem that where we can build our distributed data platform, data services, all the federation part. And on the left side, somehow is where our stakeholder can benefit from the business value out of the data. So where we can create a real, I would say, benefit of adopting Dataspace in the manufacturing domain. This is just the ending of the presentation where you can find our contacts. Me, as mentioned by Silvia, as we have been leading the work of this blueprint. Oscar from Innovalia, that is the project coordinator, and just get in touch with us in order to exchange more information, more insights, and whenever. And that's it from my side.
Yeah. Thank you very much, Angelo, for insightful presentation. And now we have Willem Datema from TNO. Okay, Willem, that you will cover two topics. Yes. One is the healthcare use case, but also you will demonstrate how you use decentralized identity management. Floor is yours. Thank you. And thank you, Angelo, for your presentation.
Yes, hello everyone. My name is Willem Datema. I work at TNO, more on the technical side of data sharing. We contribute to the TNO Security Gateway, which is an IDS compliant connector, which was recently certified. And the current focus is on the implementation of the Dataspace protocol, which was covered multiple times this morning. And today I'm going to talk a bit about the health Dataspace use case that we are working on in a separate project. Because a lot of benefits can be gained from sharing health data. AI applications can be used for faster and more accurate diagnosis. And also one other use case is health monitoring and preventive care. But of course, health data cannot be shared freely. There are strong regulations in Europe, and one possible solution is to use privacy-enhancing technologies, which enable computations to be done on data without the data being shared. And the concept of this is very nice, but it scales badly on its own. So we are looking to combine the data spaces with the privacy-enhancing technologies to deliver a good scalable solution for gaining insights on data while the data stays where it was originated. For this, we use the control plane and the data plane, like Sebastian already briefly explained. The control plane handles the Dataspace protocol communication, and as data planes, we use MPC algorithms in this case. And this is also the link to the identity here, where we have a wallet for each control plane, which covers the credentials of each company, which I will explain a bit more about later. And the credentials are issued by a Dataspace authority, which is the issuer. And these credentials are all shared to everyone in the dataspace, which will enable a registry to use those credentials, where to create a registry where the participants in the dataspace can be found. And this is also a Dataspace protocol communication. So we are trying to move to self-sovereign identities in dataspaces from a concept that was used before with the certificate authority. They handed out certificates to each participant, and it was a centralized solution. And we are now moving towards decentralized identity structures, so that participants can be in control of their own identity. And also, my slides are gone. Let's see.
We can see your screen. Okay.
It's back. All right.
Can you put in presentation mode? Oh. Great.
Now we're back. Okay. Yeah, I also got the message if someone else had, but okay, it's fine. The decentralized identity can be reused across dataspaces, which is a great benefit. And how it works is that there is an issuer, which is the Dataspace authority, a holder, which is a participant, and a verifier who can verify that the holder has actually received this credential from the issuer, and they are all doing this through a verifiable data registry. The terms that are used within self-sovereign identities are DIDs, VCs, and VPs, and I will explain these in the context of the Heracles project, in the health data sharing project that we have in the Netherlands. So participants are required to host their digital identifier. They are linked to the domain of the participant. So everyone that has a domain can have the decentralized identifier, and it is hosted on this document, and it has some information regarding proof. There's a signing proof there, and there's also a services field where the owner of the DIT can say where the specific services are located. And this is used behind the scenes to help in the navigation to the dataspaces participants. Using the decentralized identifier, they can ask the issuer for a verifiable credential and store this in their wallets. This is displayed in the picture here. So there is a participant that has already got their credential, and this credential is saying, okay, this participant is a member of this dataspace. And in this case, it is a data provider, which is the role. And then the participant can use this VC, verifiable credential, to put it in a verifiable presentation. And this will be verified by another party. And with this validated verifiable presentations, the partners can communicate. And I will also now share a quick demo, which this process of identity is being performed in the background. So every request that is going to another party will be done through the verifiable presentation request. So we are here at the fictional Health Harbor Medical Center, which will send a catalog request, which is the dataspace protocol call to, in this case, the data guard, which is another fictional company in the dataspace. They will send a catalog request, and they will see what data sets are here. In the future, we will have another data set here, which is the MPC data set or the data plane. For now, we only have this enabled, and they can negotiate a contract, which will by default create a permission, a ODRL offer with a constraint that the other party needs to be part of the same dataspace as we are. We can send this, and it is really in development phase, so I have to send it again. And then we will see it was sent successfully, and the other party can view the contract negotiation, see if he agrees or not, and if he does, he can accept it. And then the contract will be available for signing, because there might be some changes over if the party doesn't accept it right away. If they are accepted, then the first party will sign the contract, and the other one also has to sign it. And then we are at the phase that we can actually start the data transferring. And that can happen from the last negotiation, which is here. He can request a transfer for data. And if this happened, then the other party can start, resume, suspend, or decline. And that is very quickly what the dataspace protocol does. And of course, in the future, these steps will all be automated. For now, we just keep it manual, so we can show the actual steps of the dataspace protocol, which were presented this morning. Thank you very much.
Thank you, William, and thank you for making the big effort to join two presentations in one, okay? The identity and the healthcare use case. And now we go to the last presentation, but not for it less important, with Sebastian, who will introduce us deploy European manufacturing data space. Okay, Sebastian, please, the floor is yours.
Okay, yes, but I think you meant the European mobility data space, right?
European mobility data space.
Okay, just let me quickly jump to my first slide. Okay, yes, so let's dive into European mobility data space activities. Maybe first some words about me. I'm Sebastian, working with Fraunhofer, and at Fraunhofer I'm responsible for all mobility data space related activities since 2016. So I have a very long history in data spaces already. I was responsible for the technical design of the German mobility data space back then, based on IDSA RAM4. And we did the whole implementation of the services. And now I'm also curious how IDSA is evolving towards RAM5. And we will see how this could contribute to the European mobility data space. So we have two projects. One has finished already. It was the preparatory action, a CSA, like many of the other data space projects. I won't go too much into detail because the project is finished and all the deliverables have been published already, and you can find them on the website. And currently we are working in the deployment project, which is a much larger one. But setting the scene, Matthijs already showed it. Originating from the European data strategy, we have those sector-specific data space initiatives. Mobility is one of them. And specifically in mobility, we have the challenge that there are already many initiatives existing out there, and mobility itself consists again from various subdomains like rail, aviation, road transport, public transport, and so on. So it's not one mobility domain, but actually very many silos that have their own initiatives, their own standards, their own governance bodies, and so on. So mobility data space is more working towards interlinking those initiatives and striving towards interoperability between existing initiatives. Yeah, and some of them are already embodied as data spaces, like the German mobility data space, like EONA-X, for example. In Belgium, there is the Flanders Smart Data Space, for example, emerging. So we have already a lot of initiatives going on, and unfortunately already using different data space architectures and implementations. So back to the preparatory action, we worked along the DSSC blueprint and did a holistic analysis of the mobility sectors, their use cases and requirements. And for each of those building blocks, we came up with very specific recommendations that you will find in the respective deliverables. And those recommendations that we developed here are now taken up in the DeployEMDS project, which started in November last year, and now we are moving rapidly to implementing use cases and then the data space architecture. We have a very large consortium, almost 40 partners here. So quite a lot of activities going on. And of course, main focus from a data space perspective is to foster data interoperability, sovereignty and trust regarding data provisioning, data sharing, and discoverability and accessibility of the data that are provided. And we are striving towards a real-life implementations project. So we only have 50% funding. So the use case partners are very eager, also with their own co-funding, to really bring operational use cases into life. And to facilitate that, we are providing a common technical data space infrastructure and the necessary governance and legal framework mechanisms. And we have 16 use cases out of 9 different regions and cities. It's mainly cities, but we have also regions with each very different use cases. Some of them are overlapping, but we have a large variety of stakeholders and requirements, how they want to implement their use cases. And so to give you a brief overview over the project, so we follow a very holistic bottom-up approach. So what we have our 9 use case regions here at the bottom. They provide requirements to the technical data space architecture and the governance legal framework. And they both will provide then the solutions back to the use cases to be implemented. And now I will show you a little bit where we stand in this work package 2, which then elaborates the technical data space infrastructure. So as mentioned, we are approaching that from the bottom up. So we are looking at the use cases and the regions. What are the stakeholders? How is the use case described? What data will be provided, and so on? And how will it be used in the application later on? And besides that, some of those implementation sites are already connected to existing data spaces like EONAX, like the Flanders Smart Data Space, like the German Mobility Data Space. So we not only need to understand the use case requirements, but also what does it mean to have them already participating in data spaces, and how can we, let's say, find interoperability mechanisms to interlink them. And first step is to map them on a functional level, the requirements. So already here again, we make use of the DSSC blueprint that has been shown previously. And when we understood what functional requirements are needed, we then in the next step will map them onto actual data space implementations. And also here, we didn't want to exclude one or the other beforehand. So we also will do a holistic mapping what implementations will best suit the requirements that we've seen. This ultimately will result in a data space architecture. We will implement this as some kind of test bed that the use cases then can make use of and deploy their connectors there, make use of the data space services like catalogs, like trust mechanisms, identity management, and so on. So we are currently at the very first step, and we are approaching the use case requirements analysis process in a very holistic way. So we are starting with understanding data as a product. As Sebastian talked about that already today, we will try to map this to data space capabilities that would be necessary to facilitate that. Towards the end, what kind of implementation can meet these requirements? And we are at this point at the moment. And we really made the use case stakeholders think of data as a product, and how can you refine a data coming from a source towards providing that data as a product into a data space. What is needed along this pipeline? What data space building blocks are needed from the data space operator, and what is expected from the consumer to make use of the data. And we already came up with very sophisticated architectures for the data provisioning side, peeking into each of these blocks here. And we conducted very extensive interviews and canvas sessions with the use case owners in order to really understand what they are planning, but also to make them understand what they could expect from data space building blocks, to make them aware of what capabilities they can plan into their use cases. I won't go too much into detail because you will find this in our requirements analysis deliverable, which will be published in the next days. We then dived a little bit deeper into the capability. So again, we employed the Dataspace blueprint from the DSSC and mapped the requirements onto the capabilities from a functional perspective in order to see what is needed, what is missing, and so on. We employed very sophisticated tools here. So this was a interactive diagram that could be used to identify which requirements are mapping onto which capabilities. And ultimately, we come up with large tables that show us which use case and which product offer requires which Dataspace capability. So having that finalized, our next step is now to evaluate which Dataspace implementations can meet those requirements. And we already started a little bit screening what is out there. IDSA we have seen today, and the EDC implementation and its Dataspace protocol, but there are also other implementations out there. So we are also looking at which of them could suit the use case requirements, but also which of them are fitting together. And we are not only looking at that from a functional point of view, but also from a non-functional perspective. And maturity is one of the key requirements in our perspective, because the use cases and the stakeholders, they are investing much money into this project, and they expect mature software components to be operated. So we will sort out Dataspace implementations that only follow the happy path, for example, and not covering the whole life cycle of a specific aspect. So maturity is a key aspect in our project here. And this will then be the next step. So today we are here. We finalized the technical requirements. Actually, today we will deliver this deliverable to the European Commission. So we expect to publish it in the next days. And you can then read, of course, the whole approach that I presented on 130 pages, roughly, to follow our approach. Then we are now entering the phase of understanding Dataspace implementations, and this then will evolve into a Dataspace architecture and a technical specification, which is due in October. So we are working on that over the summer, and of course, if we may align again in the future, I can then around October present you what Dataspace architecture we came up with. So that's roughly our project. Please feel free to reach out to us. And back to Silvia.
Thank you very much, Sebastian. Very interesting, and for sure we will contact you again. So now we have some minutes for a couple of 3 questions. So all speakers, if you can open your camera, and please, if there are any questions from the audience to the different speakers, comments, just unmute or raise the hand or unmute yourself. No questions? I am going to share with you on the chat where you can sign for PLIADES newsletter and to get informed. Okay. No questions on that. Do please, Angelo, Willem, do you want to add something or comment something on top of what you already? Okay, no comments. So I think we are.
Silvia, just a small comment. related to the fact that in PLIADES you have to, I mean, the main challenge may be also to find the right way to federate existing data space from a cross-domain perspective, while in the different examples that has been shown today, I mean, in the second part of the morning, they have been mainly focusing on just one domain. I feel that all of us will benefit from your, I would say, requirement specification for this federation aspect. On the other side, also your kind of guidelines on how to deal with this federation, since we, I mean, as vertical or domain-specific data space may benefit from your understanding of this aspect. So I think that this could be also sort of I don't know, recommendation document, whatever could be the form that probably you have already in the plan, but even if it's not, probably something that can be really valuable for the rest of the community. So please take into account in case you want to also disseminate back this kind of feedback. So I would appreciate it very much from the manufacturing perspective, but I think that is true also for all the others.
Thank you. I think this PLIADES project it's a great project because what we have seen for the moment is data spaces implementations that are in one domain. Sebastian has introduced that despite they are on mobility, inside mobility, there are different communities, so a lot of challenges to make it interoperable. So I am sure that we will follow what you are doing and learn from your experience because you are one step forward. And here in PLIADES, we will see how we can contribute to this interoperability federation in order to develop tools or a data space or tools for a data space that is not focused in one specific sector, is cross-sectorial, and how these tools can be used in different domains or sectors under the same data space. Dimitros, do you want to add something just before we close?
First of all, I would like to add my deep appreciation and a very big thank you for organizing this excellent workshop. A big thank you to all the presenters, and thank you very much. It was a fantastic ensemble of different views of starting with the IDSA, the protocols, the technical descriptions, and moving on to real implementations and projects. It was fantastic ensemble. Thank you very much, Silvia, for organizing this, and all the presenters who made this a really fantastic workshop. It was very insightful, also for us. Of course, you know that I come more from the robotics domain. You are the experts here on the data spaces, and it is a very good opportunity to hear you, to understand better in a very clear way what is the status, what are the challenges here, and how we can contribute as a research project into real problems, contributing to real problems, solving real challenges, and trying to put further contributions in these developments from our side. Of course, moving into practical, let's hope to the biggest extent possible, practical outcomes by the end of the project in interconnection, different data spaces in the domains that we have. In case, again, a very big thank you from our side to you and all the participants of this workshop.
Thank you, Dimitros. And thank you all of you for your attendance and participation. Bye.